Welcome to the Town of Richmond special meeting of the Water Sewer Commission. It's October the 7th, 2025. Public comment?
It's raining.
Yes, thank you, David.
I never thought I'd be glad it's raining.
Don't be too glad.
Yes. Additions, deletions, or modifications to the agenda? Moving right along. We have basically really one item tonight, broken down into 3 sections. So we have several of the individuals from Boyletown are here tonight to give us a good explanation of our 20-year study. So, first up, as you talk this, please state your name. And first up is review of and consideration of accepting the preliminary engineering report for the wastewater treatment facility in 20 years.
All right, so hello, everyone. I'm Kirsten DiPietro Warden. I'm the lead technical engineer for the wastewater treatment facility upgrade project. I also have here with me Eric Doe, who is working on the Bridge Street pump station upgrade project, and Aiden Short, who will be presenting on the user rate study. And we also have with us Sarah Foy, junior engineer with us, who is observing and taking notes for us tonight. So she really wanted to see like a real live water and sewer commission. So I was like, come on.
Washi, anytime.
I am going to talk about the wastewater treatment facility 20-year evaluation. And then I'm going to hand it off to Aiden to talk about the user rate analysis and the loan payback alternatives, because that's his. And then we'll turn it over to Eric to talk about the pump station. So we can go to our first slide, Josh, and
There we go.
there we go. I've already said what we're here to
Yeah.
what we're here to talk about. We can first slide. So one of the, maybe not the meeting before, but a couple meetings ago, it was conveyed to us that you wanted us to kind of re-look at the treatment facility and kind of take a look, take a step back and sit down with Steve and see like what absolutely needs to happen first, right? And what needs to happen, what's most critical, and how could we reduce the costs of the whole upgrade, and what are things that Steve and his staff could do themselves to save some money. So we put our brains together, and this was at the beginning of the summer, and we came up with what I'm just calling a pared down project. So I have a recommended project for you that has been broken into two phases or 2 contracts. I'm going to say it that way. But first, I just wanted, this is quick. I'm going to go through pretty quickly, but just each area of the plant to tell you what we're going to do and what we cut out. Okay. So we can go to and you can go to the next slide. So influent pumping. So as you know, Steve bought 1 pump. We designed an upgrade to the existing pumping system to turn it into a triplex pumping system to convey the peak flows that the plant is seeing, because that is a real bottleneck at the plant, and it's a real concern. If we can't convey that flow through the plant, you're going to flood, and you're going to flood into the park. So to that end, Steve has already purchased that first pump, and he's in the process of installing it right now. He's done.
It actually came today, the
Yep.
pump you guys approved. Demolition, the old pump's already removed. We've got some more demolition to do. And reworking of the valves, but it's on its way.
So owner's scope here is to replace that one of the 2 existing pumps. The contractor scope would be to upgrade to that 3 pumping system. So 1 has already been purchased, and then they'll be installing 2 others. Like I said, to get us to that peak instantaneous flow. And basically the criteria is that you need to be able to pass that peak flow with one pump out of service. That's why we're moving to a triplex, because you can get a better turn down if we can split that peak flow between two rather than just one on one. So that is the pared back scope. This is still a critical piece of infrastructure that needs to happen. So that is the recommendation for the influent pumping area. We can go to the next slide. The cost for that, this cost has been pared back to just show that the two additional pumps, the VFDs that will go with that, level control system. We do need to upsize the force main from the pump over to the headworks.
Okay, all right,
We do.
that's what I was asking.
Yeah, it's.
I was curious what that force main
Yep,
was.
that force main is not hydraulically, and when we're in final design, I can reevaluate that with the pump manufacturers to see if the heads are excessive. But my first, in preliminary engineering, it was too excessive at that peak instantaneous flow. But we'll definitely, as we design it, going forward. But that is the price tag, about $500,000 for, and this includes, so I just also want to back up. Couple of caveats. This is tied to April 25 ENR index, which is only going to become important when I show you the costs at construction time, because I will then escalate them to when you are going into construction. Okay, so the numbers you see here in these individual cost estimates are tied to April 2025, and these include that contractor markup, which is, their overhead and profit. It's their mobilization and demobilization. It's their bonds, their insurance. It includes all of that. And it also includes a contingency for tariffs, because we just don't know what's going to happen. Okay.
It's my understanding that the 3 pumps are supposed to all be flight. I mean,
Yes.
it's basically what we decided. Our one pump is significantly less than half of what 175 is. Is that the installed price?
That's the installed price.
Okay.
That includes installation, that includes valves, that includes,
Yep, okay.
that's,
All right.
you have piping and valves, but that's like getting it in there and pipe and
Okay.
all the controls for it as well. So that's installed. And yes, it is a little bit inflated. I usually carry
No,
about,
that's, I mean, I'm fine with that. I mean, I'm just trying to.
yeah. I
figure it out.
usually can carry about 30% for installation on a pure cost from a manufacturer.
The contractor, will this go out to bid?
Yes.
to different contractors,
No.
or are there certain parts of this that like the person that we're buying this stuff from has to install? it?
No,
No, it'll be
we'll do one general contractor.
for everything.
For everything, for the whole plant upgrade.
Okay.
Yeah, so hypotheticals, okay, let's say it's a PC construction or it's a Penta Corporation. Penta did the upgrade before. Negley Chase does plant upgrades around here. Maybe it's one of them. They will have an electrical subcontractor, they'll have a mechanical subcontractor. They might have a purely someone who does pipe fit up, that does that kind of
Yeah.
pumps and things like
So
that.
we aren't trying to organize all
No.
that. There'll be
Yeah.
one company.
One company, yep.
It will be overseen though by us.
Oh, by the Steven.
You can go ahead to the next slide. Okay, headworks. So let's move in this slide. So we went back to the two alternatives that we had in the PER. And in the original PER, the recommendation was to build a brand new headworks. Well, not brand new, but kind of reuse the wet well and put in a screening piece of screening equipment that could take we call them rags, take rags out of all the gross stuff out of the channel before
They
the
came and
pumps.
took a tour.
Okay.
They pretty
They
much.
know.
Headworks is the building that you like walk up to next to the wet
Yes.
well.
Right.
So we were originally envisioning transforming, retrofitting that deep wet well, putting like an intermediate floor and putting a building above it to get
Okay.
headworks and screening before pumping. And the reason is ideally you'd like to protect those pumps.
Okay.
Okay. we saved a lot of money by going back to alternative 2, which is just to replace the equipment in kind in the building that you toured.
Currently.
So this alternative, the recommendation is to replace in kind. So the contract, it's all contractor scope. This is not, none of this what Steve would do. And this is basically replacing that unit with a Headworks acceptance plan, which it's kind of a package, and it's a package micro strainer and grit removal all, and we have to kind of, has to go, it's pretty custom. It has to go into that space that's there right now. I have found another manufacturer who could do it. So we could have
Okay.
competition. So we'll,
mean,
we can,
Yeah,
we can talk about that. But this is the alternative 1. Whereas before we were looking at a new Headworks building, which was alternative 2. So we can go to the next slide. And it's still pretty pricey. I mean, that screening unit, and that's installed, is, $750,000. We will need to take part of the building off to get the equipment out and to put the new piece of equipment in. And I don't have that thought through yet or designed, if whether I'm taking the roof off or if you take the side off. I don't know yet. I'd have to,
So this is design specific to the space that we have.
yeah, we'll be just replacing that piece of equipment.
Whereas if you just came and said, we need a new building, then you could buy off the shelf equipment and.
No, it still would
No.
be custom. And the price was, I think I think I shaved off about $1 million, $1.5 million by going this route.
the reason we're so limited with our Headworks building is we need to have access for the tractor trailer. So we
can.
can't go wider.
Yeah.
Our only alternative is to go up, which doesn't work. We can gain a little bit of length, but not a lot.
Yeah, I mean, in an ideal world, I would put this outside of the fence.
Right.
Right, I'd put a standalone building somewhere on the influence sewer outside of the fence. Problem is, you're in a floodplain.
Mhm.
And that will never get permitted,
Right.
ever. So,
That would be before the wet well even.
Yeah.
Right.
You'd rather have,
I-
the headwork should be first.
Right.
work should be
Well, that's
absolutely first.
Ideally, that's how everything would be. You get your rags out, you get your
The grit
grit out
out.
before it gets to your pumps.
But the headworks also starts the treatment process as well.
Well, ours does because it has the anoxic zone.
Yeah,
I mean, that would be still in,
yeah, the anoxic zone would stay where it is.
Well, the big tubes that sort out all the grit would come, and then it would go through the wet well, the influent pump, and then the anoxic
Right.
zone,
Yeah.
and then the aeration tank.
yeah,
Exactly. The
that would still be the same
And then
thing.
the rest of-
This is probably a really dumb question,
Oh.
but why can't we just pump it into Headworks instead of into the wet well?
It comes in by gravity really low, like, how, did you walk down?
Yeah.
The influent gravity is way down there, so that goes into the pumps that then pump it
Okay.
up to the headwork.
And ideally,
So that, it's not a. dumb question,
ideally
but that's-
back by the gate was where the headworks should be.
Yeah,
Yeah.
In the, if we could go back to
yeah,
63.
and if
it-
they let us build it a full
Right.
thing.
Well, back then they would, but, it would have been installed there pre-pumping.
Mhm.
Yeah,
Once the pumps, then the pumps would just pump to the anoxic
Yeah,
zone,
to the start
and
of
then it
that
would flow through
treatment
the
process.
plant. But
So we just wouldn't be able to permit where we are today.
There's
Mm. no way.
no way.
You can't build up, they wouldn't allow.
Well, it's all, it's a hydraulic thing.
Yeah.
It is low where it is. There's nothing. I mean, I even thought about, could we do something on that slope? But again, the cost of a new building will be, I would say,
Considerably.
considerably more. Like if this is 1.3 million, a new Headworks building's gonna be like 3. So this is a cost savings. And this is not a bad solution. It's been working.
No,
And I think with the way that Steve has been proactive in operating his wet well, he's not, I mean, I don't mean any, the way it's been operated in the past was to let that wet well kind of flood up and that was to gain some capacity in the plant during heavy wet weather events, right? Big wet weather events. What would happen if that was all one big, if all the flow is just coming in there, it's not getting screened. There is a bar rack, and so you could get rags and stones.
Well, there
and
wasn't even a
sticks.
bar rack at that time. It was taken out. We
ta-
put the
you
bar
put it
rack
back in.
And yes, the plant operates much better the way it is.
And so he has protection in front
Yeah.
of the pumps in that manual bar rack. He does need to go down and clear it every once in a while.
Every day.
But if we keep the operation of the wet well for the pumps, like at a draw fill and constant level, he shouldn't have the issues he had before.
Yeah. Which
Like
we don't, we haven't.
historically.
And I,
So.
and I've relayed that, the bar rack is eliminating a big chunk of change, but we still need to get the grit and the rags out of the system and
So, yeah, ideally, it would be great if it happened before. Steve has made operational changes that are working for him. So
But the headworks would have done that.
the head work
Yeah.
would have done that.
This is another tangent question,
Yeah.
but I assume we will have to keep running while we're under construction.
Absolutely.
Do we loop back to that later?
Yes, we can.
it's all doable.
I'm sure it is. I just was sort of hadn't crossed my mind.
No, yeah, it's a very
I was
good,
like,
it's a very good observation. It's a very good, and it's like one of our
No,
biggest
we're not.
challenges.
We're gonna stop the flow from town for a week.
They couldn't stop washing their cars when there was a
People watching their cars.
water ban, so.
It's a very good question. It's like one of the toughest things for us to figure out. It is.
It's doable. I mean, we went,
You can do anything, Steve. I have confidence in you.
yesterday, we cut the flow coming out of the plant by half. We switched aeration
Okay,
tank.
I was gonna say.
So we no flow from 7 o'clock till 4
Yeah.
o'clock last night.
So there are ways, and that'll be
Yeah.
something that we really explore during final design, is like, okay, how are we gonna build this? Like, that's like, how do you sequence the construction?
You just
so
have
that
to, you have to make plans. It's doable though.
Sometimes it involves like bypass pumping, sometimes you have to not be using.
Not all of the processes will be used at certain times.
Right.
And the state's okay with
And,
that because.
sometimes, screening, there's a lot of plants in Vermont that have zero screening
Yeah.
and zero grit removal. So yes, it's a pain, short term, but Steve can operate
Yeah.
that way. And maybe we put in a finer bar rack down in the wet well temporarily while we're swapping out the pieces of equipment.
That one gets pretty much, we get 5-gallon pail every day
Yeah,
off that.
yeah. We can go ahead and move on. Biological treatment, these will go pretty quick. We're not gonna do much here. Those tanks were just flowing through. The only thing to happen here is, okay, maybe I should just back up. The original plan was to switch to a compressed gas mixing system, which is fairly new technologies. It's really energy efficient. We were gonna switch to that because we were gonna utilize that same type of mixing over in sludge holding. We have, so in the sharpening our pencils, kind of decided that it's expensive, right? And what's working now, what he has now works. So let's just stay with alternative one, which is submersible mixers. They're very low horsepower. So it's not like it's gonna be a lot more energy costs or anything like that. It's a very low horsepower motors. There's 3. Steve is gonna purchase them on his own directly, and the contractor will be in charge of doing any electrical and instrumentation associated with them.
Those are in the bubble tanks?
No,
Those are in the, those are,
Headworks building.
Next part.
No,
those are in the headworks tank that was below
the slab.
the
Oh,
slab where
yeah.
those
Lift
3.
the trap
yeah.
door up.
Yep.
Okay.
Yeah, you
Yep.
can't see them.
They're,
And even if you
those are
look down, you
they're
wouldn't
like,
see 'em.
all they are is a motor with an outboard prop on them.
It-
Okay, I remember.
And it just
now.
keeps everything spinning. And,
Yeah,
yeah, they're about 16 grand a piece, last one we purchased. I think we should replace the other 2 because we've replaced the prop on one of them. It literally was worn to nothing. But we did that with a spare prop that we had. So the other two, one has been replaced, the other two we should replace. And that's not a problem.
They just go on rails, it's very
Nope.
easy.
Yeah, we replaced the other one.
So
We get Dan
everybody-
Pratt to come in and just do the wiring and.
So, this is a significant savings that we found, and this, I threw 12 grand at just process electrical and instrumentation, and
Yeah.
some of that is just, sending sensors and alarms to SCADA,
Right.
like we do plan to do a SCADA upgrade, so there's a token amount there. We can move to the next slide. Biological treatment, the aeration tanks. So this was another area that we looked at. Talked with Steve, and he thought that he could replace all of the aeration tank diffusers.
Which one tank is now completely done already. We switched to it yesterday and it's working great.
These are the bubble tanks.
Yeah.
Yes.
It is giving us, we have never seen a more even mixing than it has doing right now.
That's great.
And actually, we didn't even see a change in our biological anything. Everything was right on track today when we did testing. We were really happy with
That's
it.
great.
So we changed all the diffusers, we plugged a bunch of leaks. It took us a while and now we've got the other tank drained, which we switched. It's been in operation for a year and literally there's hardly any solids in the bottom of that tank. We're gonna just rinse them right through back into the wet well and it'll come right back through the plant. And I think we're gonna be all set. We'll change all the diffusers in that one. We'll probably end up filling it with effluent for the winter, but it'll be all set and ready to go next year. We won't have to have downtime with it like we did right now. So the two aeration tanks themselves will be set. The problem is the problem we run into is we can't aerate both of them at the same time. So we can't we have to juggle between the two.
Yeah.
While we're draining one, keep this one aerated, switch back to this one to keep everything happy. So that is where we need
Yeah.
bigger blowers and
Yeah.
some piping.
So the contractor scope here is to replace the two existing blowers. The ones, I think you saw them, they're kind of tucked into the back of the building behind the filters.
Yeah.
Replace them. New, DO stands for dissolved oxygen probes in the
You
aeration
need
tanks.
those.
We're gonna get rid of that air intake from the sludge holding tank. We're gonna put a new discharge, air discharge, so you have two separate feeds to your aeration tanks. Valve modifications, new airflow meters, SCADA integration for that DO, that dissolved oxygen probe, so we can have so we can fine tune the amount of air, with the blowers. We can set up a control loop, to automate how much the blowers put out for air dependent on how much the biology, the microorganisms need. So we'll put in that kind of automation.
It's interfaced to the DO meters.
Yes.
Yeah.
So you can set a set point and we can talk more
It's
about,
much more efficient and it's
We'll
a electrical savings.
yeah, you'll see energy savings by doing this. And that particular control loop is eligible for Efficiency Vermont rebates. So there is some like incentive dollars to put things like that in. Okay, so that there can be some savings there. And that is something that during design, we bring them in to see like what can they pitch
Yeah.
in for some of these like electrical incentives. I just want to go back to the blowers. We are going to, I left them in here in the cost estimate, if you want to go to the next slide. I left them in, but we are going to bring in the manufacturer's service technician to take a look at them. It could be that in these earlier years, like, let me back up again. Typically, you size a blower for your full flows. you know, like what the aeration requirements are at full flows, and you're nowhere near that, right? So, it's possible, but these blowers, the condition of them aren't bad and that they'll be okay for a while longer. And so I'd like to bring in a technician to kind of look inside of them, see if there's any corrosion, because we had the brilliant idea 20 years ago to bring air from the septic holding tanks over, which was not such a good idea in hindsight. So there could be some hydrogen sulfide corrosion in there. And so they would take a look to see, and we would run just some blower tests on them to really see what they put out and if they are suitable for the design points we need right now. If they are not, we'll replace them. If they're okay for now, this could be something you put off for maybe 5 years, maybe it's 10 years. You know, this could be an item that could be put off. So anyway, new blowers, it's a pretty big price tag, you know. It's about a $250,000. We have,
Is it the intake thing that makes so much noise or the blower?
The blower.
Well, the blowers make
Silence.
noise, and this summer when it was so hot, I switched to sucking,
Right, the
Fresh-
outside air.
yeah. And truthfully, I mean, you guys were there while the blowers were running. It's not that loud, but there are mufflers and stuff. We can make it quieter.
we can make it quieter, and newer blowers today, some don't even have outdoor air intake.
Right.
They just take it from the room. So there's been a lot of improvements over the last 20 years.
Yeah.
On silencers and these blowers themselves.
So-
So that is definitely something that can be improved.
It didn't bother me, but
Okay.
I just was making sure I had
No.
the right piece of
Yeah.
equipment.
So, you know, there is some programming with electrical instrumentation and SCADA programming and air piping and valves. So this price went down, if you can see, by about $65,000, but actually that's before all the multipliers. So it actually, the savings were better than that. So just to point out where we had some savings that came off, I struck them out in the cost estimate.
Yep.
Like that. We can go ahead to the next slide. So chemical feed, basically what we need to do here, the recommendation was, the containment doesn't meet standards right now. So we need to add a little bit of height to that concrete. That can happen in a couple of ways. We can drill in and put concrete, or Steve could come in with some cinder blocks and just make it higher.
No, we've already anticipated doing something with that.
So, yeah, increasing the height
Yeah.
and then new chemical feed pumps, valves, and this is all scope that Steve feels comfortable doing.
Yeah, I mean, we really wanna, and I've talked to you guys before, but the workhorse LMI chemical feed pump that we have throughout our plant and a lot of plants out there, there are better options nowadays.
Way better.
Oh, and,
Yeah.
I really think we should look at, switching our chemical feed pumps to a new style.
And we can, with these more sophisticated feed pumps, they have controls. We can do a lot of automation that will cut chemical consumption down, which is savings for the town,
Yeah.
right? Because this coagulant, this is what we use to get phosphorus out of the wastewater. It's expensive, and the prices are just every year go up and up and up.
I mean, I just got 1,200 gallons of sodium aluminate. It was $7,800.
So this is another area where we can decrease operating costs on an annual basis. And that would be by putting in like upfront, like some analyzers. If we can put phosphate analyzers in to trim the phosphorus, and it just automating it. A lot of plants see these kinds of savings when you put in this automation, this online automation. So you can go to the next slide. Again, this came down quite a bit in price because Steve says he's going to do some of it by himself. You can see the pump skid, the chemical feed pump skid. It's about a $20,000 skid piece of equipment. But
And that's for two?
that's for two.
Right, and
It's a
it's
duplex.
self-contained, it
Yep.
basically just,
It's just you pipe to it and you pipe out of it. It's like plug and play. So again, we cut the costs down here.
Steve, remind us where that building is, or that?
it's in the basement underneath the filter room.
Big,
It was that large sodium aluminate tank.
We were going down back.
Yeah,
Back in the.
yep. It's that tank in the corner.
That's a little 2 foot or 3
Yep,
foot. wall.
that needs to come up about 8 inches.
Yeah.
To give us adequate containment for what they want. And then right now, we have just one feed pump from it that pumps out to the beginning of the clarifiers.
like constant
And
paste.
it's ideally, there's supposed to be redundancy there.
Yeah.
If that one dies, we really don't have anything. Yeah, we grab a 50-gallon pail and stick.
The feed pump there, is that something that we could add after?
You can do this
We wanted
anytime.
to,
You
like,
do
can,
this anytime.
the instrumentation and getting it into SCADA, it would ideally be done at the same time.
That's a really good point. The systems integrator would come in and he's gonna run all these wires from every place. I mean, to that end, it's possible to run extra wires and just have them there that you could hook up later. It's possible.
Yeah, I mean, ideally, I mean, we have the ability to see what is happening with their sodium aluminate now, but we don't have any control of it.
Yeah.
And this would give us a little bit of control.
I think it'll pay for itself.
Yeah.
In chemical savings. Yeah. It definitely will. All right, we can go to the next slide. Return activated sludge and waste activated sludge pump systems. I call these RAS and WAS. RAS and WAS. So Steve is going to do any kind of valve replacements. I think you've done most of them already, right? On the WAS side of things. Suction and discharge off of that Penn Valley pump.
Not on the RAS or the
No,
WAS.
no, okay.
But it's not a problem.
Yeah.
I mean, anything we need to do with the plug valves, we can take them
Yeah.
apart, rebuild them. That's doable for
So
us.
the only thing we took out is that, because that's very much, Steve feels like him and the.
I mean, we've done a
Yes,
lot
yeah,
of
can
them.
do, yeah. So this is a, RAS is controlled by a pinch valve because it's all flows by gravity. So it's just this big, it's this valve that, it's got a bladder, it looks like a water bottle or like a water bladder, like a hot
Okay.
water thing. And what happens is the valve just pinches it from either end and it controls the flow. So that's all it is, but the thing is
So we
over
have
20
it
years
set,
old.
so like right today, it's set for 70 gallons a minute, flow through it. Or we can throttle that down and it adjusts itself. Or like when we're wasting, we shut it off totally and it closes. It stops that build up in the clarifiers, the sludge that builds up in the sludge dumps from going back to the wet well.
So you're constantly trying to manage that solids level in the clarifiers because it's all part of the biological process. Like you need to remove a certain amount of solids, you need to recycle a certain amount of solids. Think of it as it's the food for the microorganisms in the biological process. So there's a certain percentage you recycle, RAS, return activated sludge, and there's a certain amount you waste activated sludge. And it's about balancing those kinetic kind of reactions that are happening in the treatment process.
Yeah, where the waste activated sludge goes?
That goes into the holding tank under the garage and then we
Uh,
mix it with septage and process it through
Okay.
dewatering.
That's what gets dewatered. Okay.
Yeah.
So the WAS comes out of the system, the RAS is returning all the time.
I have dreams about this. WAS and
RAS and WAS. So the contractor scope would be the RAS valve replacement, the electric actuator and the flow meter, and the WAS pump replacement would be a new Penn Valley pump.
Yes.
Yes, I know you love them. So, you can go to the next slide. You love them. And the cost for this is about $150,000.
Yeah.
So
Those
this,
Quakers or?
They're made in Pennsylvania, I don't know.
I'll tell you later, I saw them at WEF,
Did
and I
you?
told them, I was like, I'll be
Well-
calling you, hope soon.
I told you guys when we toured there, we've got 4 of them, they're workhorse pumps, they'll pump broken. You know, and yeah,
Easy,
Uh,
easy to.
they're easy to fix. They've made them easier to fix.
Yeah, they've made improvements that make it even easier.
So, yeah, I have talked with people who hate them. For us, they really work.
That's all that matters.
Yep. You can go ahead to the next. Okay, so filtration, those are those big blue tanks after the clarifiers it comes in. That's where we're separating solids out, and that's where all the phosphorus removal is really happening there. Because we're coagulating, we put in the chemical, it binds the phosphorus out of the liquid stream, and you create a flock, and you're then physically separating it. Think of it like a coffee filter. We're physically separating it, and the phosphorus is bound up in those solids. So that's where the phosphorus removal is happening. Owner scope, and I may or may not have gotten this quite right, because you keep doing things and I'm not sure.
Can't wait.
Yeah, so I know Steve's already changed all the cloth, the cloth on them, and you've been changing valves and actuators. And the contractor's scope would be, we still need to we need to come in and do an assessment of the steel of those tanks. I suspect there's only superficial things that need to be fixed. I am not of the belief that the whole tank needs to be
You need to-
replaced.
we need to have somebody look at them, because
You know,
there's one that has considerable amount of rust on that tank itself.
where, well, we'll talk about that.
Yeah,
later.
I mean, I have one that I'm more concerned about.
Okay.
I don't know why, but
So this is a risk. I'm not carrying costs for new filters. If we would have to replace the filters, it'd be a significant cost. Like we're talking like over $1 million for new tankage. I am of the belief that it's going to be a structural fix that we can do with a metal fabricator. So I don't think we're headed down the path of needing to take the roof off and pick up a whole tank and put in a whole new tank.
we know what metal fabricator will be.
Do they do on site?
I think
Maybe for you?
I think I can convince them to.
So the contractor scope is really around parts and pieces of the filters that would need replacement.
So this came up in talking, Shelburne is under, they're doing a new upgrade
Mhm.
to a new plant. They have 2, 4, ours are 2 disc. They have 2 4-disc ones. I was offered some of the parts and pieces
Okay,
off of theirs.
Okay.
I haven't gone over to look and see what will be available.
excellent,
But, we're gonna go salvage.
excellent. And and again, these are packaged things. If these are parts and pieces that you can take care of, it's things we can take out of the
Yeah.
contractor's
The,
scope.
the backwash pumps have already been changed. They're brand new.
Okay.
And we have a spare on the shelf. We don't have a sludge removal pump. We have only
It's
one.
just a valve, right? I think it's
Yeah.
the same pump that does
Yeah.
both, so.
The drive motors. I mean,
no
they're
problem.
there, they're old, but
It works.
they only work a few minutes
Yeah.
a day. The upgrade on the tanks that I think we need to do are the control panels. And we installed 2 new, the backwash valve and the sludge removal valve. We just changed those because on one of them they failed. The upgrades are working so good. I'm almost tempted to change the 2 on the other tank because they intermittently don't work. And those new valves will work with any PLC that we upgrade to. I've
Okay.
already confirmed
Okay,
that. The PLC instrumentation is what I'm afraid of with those
Okay.
tanks.
the control pins, yeah.
My question is, when I hear about, I think we can do without having to replace X now, is just like those drive motors. If they don't work, can we continue to function?
Well, we only use one at a time.
So we have two.
Unless we're in a flood event, we have two, and that's the redundancy of it.
Okay.
And like, we were down for over a month while we assessed what was going on with those valves and got the new ones. We used the other one fine, we drain it down, rinse it out every other week. And, just continue to use it.
It might be good to salvage one of their drive motors.
Well, we
And have it on
could,
the
yeah,
shelf.
and then that's what I mean, we would have it on the shelf
Yeah.
and stuff like that.
That's my next question, is
Yeah.
like, if you had to go out and buy X today,
I think a drive motor wouldn't be a hard, it's an I think it's an
Yeah.
off the shelf thing.
And Aqua Aerobics is extremely responsive, like they can get parts and pieces
I,
very quickly.
yeah, I was pretty impressed when we got talking to the technical people there. They had all of the blueprints for our tanks in particular and everything. And, they walked me through what was going on with the electrical. And once we verified that the valves were bad, the guy's like, you need 2 new valves. I guarantee and we got them, put them in, and they work great.
Maytag repair, oh, you finally called me, or?
Yeah.
We can go,
So, yeah, I mean, like I said, Shelburne is gonna be doing an upgrade. They're gonna have some parts and pieces. They said they would be able to take what we wanted when they get ready to go. So,
Great.
it'd be good. We can go to the next slide.
You might call over to Virgins too.
Oh yeah, they're demoing theirs
who?
for Jens. Rick.
Yeah,
So, a little bit of savings by doing the cloth themselves. There's still a significant cost for new panels, PLCs for these, and I did include that in here.
yeah, the
'Cause they're
panels
getting
are
old.
what? They're 20 years old, and the upgrades that have been made in the electrical are much better now. The ones that we have they were like first generation or something, the guy told me.
Yeah.
And
They're
he's like,
obsolete.
yeah,
They're
the
obsolete.
parts and pieces aren't available for him. Cause that was his thought was, it's not your valves that are failing, it's your panel, it's the parts and pieces in there. And the Allen Bradley doesn't make those parts and pieces anymore, so you're stuck with upgrading. So that's where I think we do need to do. The filters work really well. We don't have much problem with them, other than the control panels and some of the monitoring that goes to SCADA.
You can go ahead to the next slide. UV disinfection, so, basically, we're talking about just replacing lamps and where is it? It's the sensor.
It's done.
It's done. I think it's already done. We've replaced all of it, so,
The lamps are all brand new. And we have a brand new sensor. It is compatible to use in SCADA, so, I mean, it's not a Trojan, they're approved. It works, it gives us a number, the state has been happy with our number.
Yeah.
So I feel content with it. It was considerably cheaper.
so you can go to the next slide. You can see
I know you're a Trojan fan, but
Oh.
yes and no.
Yeah.
So we're eliminating this from the project. So we can go ahead to the next. So effluent flow measurement, next thing is, you can go ahead. This is all contractor scope. We need to replace that, V-notch weir, new radar level sensor and flow meter and SCADA programming. You can go ahead.
this is where it goes out to the river. There's an actual V notch that it flows through.
It doesn't measure high enough.
And it, whenever I have somebody come and they're like, why do you have this?
That's the
The
flow meter,
stigma, that's
yeah.
the flow meter. It just is, that particular flow meter was used.
It's an
Well-
ultrasonic, and that was pretty good technology 20 years ago.
That's a disc.
No, it,
No, well, it's beside the disc.
so there's a level sensor, and the sensor is ultrasonic. And the technology, that was great back 20
Yeah.
years ago. That's what everybody was doing, and now everyone's getting away from them because
And
it's better
everybody,
stuff.
and everybody that comes and does anything there, they're like,
Like, you still have this?
why do you still have this?
So we're gonna go to a radar level sensor, which is way more precise. It's just a
Yeah.
different sensing mechanism.
The V notch needs to be moved.
The V notch needs to be moved up and increased so that I can accurately measure higher flows.
Right.
I can, like, right now, his flow meter pegs out at a certain MPD.
When the river flows up, the V notch is actually underwater.
Yeah, so it's submerged and we're not getting
And,
accurate
and you
measurements.
just, you can't get the flow.
Catch you with another dumb question. Why do you need to know?
Permit.
Permit,
Okay.
you're,
It's not a dumb question at all.
no. You have to measure what you're putting
Yeah.
out to
And
the,
then report.
Not,
yes.
not a dumb question. at all.
every day.
And you have to measure it at the river, not.
No,
It's
at the,
Usually the last thing before
it's,
you.
yeah, before you
discharge.
discharge.
Okay.
Typically the last thing. So you can go ahead to the next slide. This is a small dollar amount. Is it just, yeah, this is a small dollar amount. You can go ahead to the next slide. Effluent pumping and outfall. So this is all contractor scope, and this is something that is critical. I think if you were in your plant tour, did you show
Yeah,
them
oh yeah.
your,
I showed them everything.
Okay.
I mean, this is the discharge to the river. And the pump station that essentially would be built on the outside of the plant.
if you wanna go to
Is
the
this
next
when we were
slide?
like wedged in that little corner?
Yep.
Well, this is the discharge, that's the discharge currently,
Okay.
but this pump station would be located on the outside.
So this is my conceptual idea. This is again, this is conceptual. This is not designed, but it's to put a little pump station out to the side. Normally, flow would just flow straight through it and out out a manhole, and then we'd put a backflow preventer before we head to manhole 14. What would happen is if the river comes up, that backflow preventer would slam shut. And if you can imagine, I'm still got flow coming through the plant, right? So I'm starting to fill up the wet well. There'd be a level sensor that would kick on 2 vertical turbine pumps located in that square, kind of where Josh's cursor is right now. Those would discharge to a higher, for all intents and purposes, let's call it a high water discharge. Like I am just
Like it's just gonna up over.
Yep,
Okay.
out the side of the river, or sorry, it's out the side of the building towards the river. I have talked to permitting folks about whether or not that was considered a different outfall, like by the permit, and they agreed that it was not, because the river is right there. If we're in this situation, we're still discharging to the same stretch of river. So this is a critical piece of infrastructure that needs to happen. You are lucky that your setup has worked
Yeah,
these years since
I mean,
Irene.
it didn't work in Irene. You guys saw the high water mark on the stairs. The sub pump that we have works. We know that it has issues. I've had a lot of issues keeping it working during flood events. And this really would stop it would eliminate that kind of flood proof the
Yeah,
plant.
and you need redundancy. You need to have one
that-
pump would
yeah.
be sized to pump that peak flow out, and you have to have the redundancy if that were to fail. So this is a critical piece of infrastructure.
That doesn't go into the tube and into the river. It just dumps off the side of the.
It's just gonna dump out.
It'll dump out in a
Same
different,
way- Same thing we're doing now, but just.
Exactly.
with
Right.
Better pumps, because right now you're using a sump.
we have a sub pump that
Yeah.
overheats and,
Yeah,
Spits water out instead of.
yeah.
yeah.
pumping it out.
Yeah.
Okay.
Yep.
Huh, I thought it was gonna go back into the pipe somehow,
Nope,
but.
nope.
Okay.
Pipes are trying to go back up into.
Yeah, I knew, yeah, that makes.
I mean, just really think of it as a high water discharge.
Yeah, I just
high
thought
water.
we were trying to
Oh,
eliminate just dumping out the side of the building. But
Hmm.
now we're just dumping out the side of the building with
I-
more.
I will-
trust That's gonna work.
I will talk with, all the different agencies about how far I can bring that pipe. I don't want to bring it into the park, right? And I'm gonna have to design some kind of, splash pad, if you will, so we're not like eroding away
Yeah,
the ground.
cause that's currently what happens.
So is it gonna, down here, these do go into the ground into a separate pipe that goes out?
Wait,
Right here, like where it comes out, or
those would just go,
or is it just gonna be a splash?
again, I just kind of showed it going out.
They're up in the air, they're gonna go out.
They're not-
Again, I have not designed this, so I have to figure out what elevation I'm actually gonna
But what I mean
put
is,
them to.
that pipe isn't gonna be in the ground.
No.
in Daylight somewhere, it's gonna go literally right outside. of
Right
the building
outside,
At some level.
at
and
some
then a
level.
Splash pad, so it doesn't erode.
Yeah.
Okay.
Yep.
Yeah.
Yeah. And I'd like to take a field trip over to Winooski. Winooski has one, Winooski has one of these, because the river floods, so they definitely have one of these, and I want to see how they did it.
Vented it.
Yep, yep.
Or access, yeah.
Yep.
So,
I mean, ideally, it would daylight somewhere towards the bottom of
Yeah,
the bank.
yeah.
I mean, currently we dump it down at the top
Yeah.
and we have had to put topsoil back on the
Yeah.
bank every flood.
You're that close to the ground at this side of the building? There's not like, there's like a still pavement on that side of the, on this side of the building here.
there's a little bit of pain.
Right, but this is all gonna be ground height, Josh.
Okay.
Yeah,
You know, the discharge to the river is, 7 feet down in the hole. And then this would be on the outside of the building.
At the same point that the pipe goes to the roof.
Right.
yeah,
But that pipe at this point would have
Yeah.
closed
Right.
because the backflow preventer
Yeah.
would shut.
and we'll design it based on the 500-year flood elevation, like we'll design it to discharge above the 500-year flood elevation, which I can't remember what it is here, but
It's high. Keep
high.
moving, right?
keeps moving, so we'll design it to not be inundated anytime soon. So, you can go to the next slide. This is, there's the price for this, and this is, so again, we didn't shave anything off of this, because this is something that needs to happen. You can go to the next slide. I think you better talk faster, I think. Septic receiving facilities, we made no changes to this. We understood from our last meeting that we were gonna proceed with septic receiving and dewatering. So the full scope that was in the preliminary engineering report is being presented here. And because I'm running out of time, I'm gonna go real quick. So I think you guys have read the report, right? Or maybe, okay, so it's the same, it's,
I mean, we tried to.
yeah, I know.
But I
it's
understand. it.
Great nighttime reading.
But you're right.
nighttime
Said
reading.
that-
Great nighttime reading. Okay, we're just gonna, new septic receiving, let's go to the next slide. I think I have a visual. We're looking at separating that room from the garage, and making it its own space. Again, this is conceptual. It could change a little bit from this, depending on the piece of equipment we put in. You can go to the next slide. This is, has a pretty big price tag, with the septic receiving unit and then modifications to make that space. Go ahead to the next slide. Also under the whole septic receiving is anything that has to do with the holding tanks. So these are improvements to those tanks, but I just want to, what differs from the original alternative that we recommended, as I mentioned before, we were originally looking at a compressed gas mixing system, which is highly efficient. It doesn't use blowers to put oxygen in, it just mixes them. We reverted back to alternative one, which is to replace in kind what is there now. So that is going back to blowers that impart dissolved oxygen into the liquid. It's a lot less expensive. So we went,
So we
and it
currently have,
perfectly, it
we
is
currently have one blower that does both tanks.
Yeah.
So you're replacing that one blower?
replacing one blower that does both tanks and replacing the blower for the outdoor, your sludge digester tank.
Okay.
So two
Yeah,
blowers
okay.
total.
You're considering the digester and all
yeah.
this?
Yep.
Okay.
So you can go to the next slide. This is the cost for those upgrades, and this again was significantly less than the compressed gas mixing. And just to note that Steve has been replacing diffusers, so we took that out of the
Yeah,
scope.
we'll have that done.
And he will be, which is a significant, if you look, that's about $100,000 in savings that we're taking out of the scope.
And this, in the digester, we're gonna be talking about the coarse bubble diffusers that we need to upgrade there. The sludge that I showed you in the digester when we had it empty the other night,
Right,
that's accumulated and it's not sludge, it's grit. And that's accumulated in just, 2 months. So, we need to get some more mixing in that.
Yep.
And get that cured.
Good, go ahead to the next slide. And then the last, well, this isn't quite the last slide, but dewatering facilities, and this is all tied in with septage, being a septage receiving facility. We're gonna upgrade the dewatering facilities. We can go to the next slide. This is all in the report. This is a conceptual layout for an expanded dewatering building.
The
It-
long thing is the trailer, the extension goes towards the old shed thing.
And if you notice, there's a wall isolating that to keep the,
Ventilation.
yeah,
Yep, so that it's. Was he dewatering on the day you did the tour?
no, I wasn't, and we had an
It was
empty.
Today when I was there.
Yeah, we had an empty trailer and we didn't have anything to dewater and they were able to see it.
Okay.
and, so, yeah, they got to go on a nice day.
Okay. You can go to the next slide. Again, these are all the things that I had in the report. This is a significant expense, but this is all part of that septic receiving upgrade. We can go ahead and go to the next slide. Trying to hurry up. Operations building, there's just some minor things that need to
Can we go
happen.
back to that other one? Just, I know you're.
Yeah, okay.
Yeah, okay.
Okay.
The feed pumps you want us to start adding sodium aluminate in the press aid?
In the press 8, we'll dose it. Yeah.
Okay,
So we'll put a chemical feed.
Yeah.
System there.
so this basically is a full replace.
Yeah. Well, we can reuse the channels that
we're
Steve,
gonna use the channels we've got.
It's the ones you.
We're gonna use the new flocculator
Yep.
that we haven't, that we'll try to get installed this fall.
Right.
We're gonna use the new, control panel that we're gonna install this fall. We've already paid for them, we've had them for a year.
Okay. there's-
Well,
so
not a
the
year.
price reflects what's already been purchased.
there's a Pen pump there as well, that's.
There's a
There's
few,
two.
two of them.
there's some pumps there, so. All right, we can go ahead.
The big thing is the conveyor.
I got a new idea. But we'll talk later. Operations building, there are some plumbing and HVAC upgrades that need to happen. And top one is I need to put an access door in that office so that Steve doesn't have to hand carry up a 500-pound pump out of the basement. So,
Went soft on this, huh, Steve?
Huh?
so.
Went soft on this.
Yeah,
So the only thing we took out of the scope was any kind of laboratory equipment, the town will buy on their own. Okay.
we've basically been keeping up
Yeah.
on that.
So we're not doing any architectural upgrades inside. We're not upgrading the lab. The facilities I mean, the operations building is pretty much staying the way it is, but we'll make some improvements to the HVAC system.
Yeah.
All right, we can go to the site. This is stuff that's in the contractor scope. New exterior doors on the process building. These are flood doors, although I think we talked about you might do them on your own. I kept them in I kept them in.
No, they need to be, the doors that I was talking about are from a water house.
Oh, okay. Sorry, so this is
Maybe
stays.
your doors too.
So floodproofing doors, there are a few doors that are below the 500-year flood elevation, so we need to have contingency. And all they are is like they're slides, you put the stop logs in if we have an Irene coming. It's not something that would stay, I mean, that would be up all the time. There's a lot of other facilities have these, like Johnson, Woodstock, they all have them. We need to do an electrical assessment of the generator and the whole electrical system. I've kept in the cost estimate, a new generator. I don't know. I'm not an electrical engineer. I need to bring in an electrical engineer to do those assessments. So there's a little bit of unknown electrically, what needs to happen at the plant. This could be something that grows, like the cost may go up, because I am not sure. We're including new SCADA programming to incorporate new equipment, a new plant water system, so you cannot use town water for certain wash up and certain functions over at the dewatering. This will save on your,
Uh-oh.
Like you could use effluent?
yeah, treated effluent. So
Yeah.
it's the after it disinfect. You can't drink it, but you can totally use it for
Could I use
hoses.
that to water the trees.
No, I offered them.
Wash the car.
So a lot of plants do this. We actually left room in that basement to do this. Is that rain? HVAC.
Yeah, but the
Gremlins.
gremlins got into.
Is it still recording even if that's not?
Oh, yeah, this is just a
Okay.
projector. Everything's
All right.
running on Zoom. We just need to get the projector.
So
We need an AV upgrade too.
That doesn't cover.
Ask the electrical engineer.
Yeah.
I'm gonna talk about the next slide. Our site slide might seem high, but we always initially in preliminary engineering underestimate this because you never know. Like when I say site, it's like everything that's below the pavement, you know what I mean? You never know quite where everything is and what you're gonna uncover, what needs to be upgraded. So I'm carrying a pretty high estimate for now, just to be safe.
That include, getting at the digester, changing some of the broken piping there.
It's kind of, I put a lot of allowances in, so I feel like there's enough buffer in there to do all those kind of yard piping changes.
That's the part that we have to over
So,
the ground.
okay, we can go, I think what I wanted to get to, and I'm sorry it's taken this long, but I promise you, this is the last few slides. It's a good thing we booked 3 hours. The next slide, phase. So what I went through with Steve was, let's phase the approach here. And we're gonna do contract one, and that's the stuff that you as a board said was important to do right up front, and that was septic and receiving and dewatering facilities upgrade. So that's under contract one. And then these are the other things are things that are critical that should happen immediately with contract one. And that is that influent pumping, making sure that we can move flow through the plant so we don't have an overflow. And then flood mitigation items are, I'm gonna skip the first two and go to the last two. The effluent pump station, so we can get flow out of the plant, and flood doors. And then the collection system manholes, making them watertight through the park, anything that's prone to flooding, and force main replacement on the bridge. So we've identified this as contract one as being what should happen first. Contract
This
two,
is the force main for septic, not for water.
The
'cause
water-
Water's already tucked up in.
Yes.
It's just the
it's the
septic.
pumps,
It's
that's not
the-
pump
the-
stations, force main.
The force main for the septic that has cost us about $80,000 twice now.
And Eric's gonna talk a lot more about that. Contract two would be the rest of these identified upgrades at the plant. as we went through, headworks and oxygen selectors, and the Bridge Street Pump Station. So that would be contract 2. We can go to the next slide. Contract 1. Okay, total prices. And so the first column, well, this is the process area. The next column is the 2025 costs of kind of what I've been showing all along. What I then do is I inflate them using a projected ENR index. I have these all, I've been tracking it, and I just make a linear projection for when you would be going out to bid. And we chose April 2027, and that's the escalation of where costs will be then. So that's kind of takes care of inflation. What you'll see is I have the different septage receiving subtotal, the influent pumping upgrade subtotal, flood mitigation, which is, the force main and those other items. I get to a contract 1 subtotal. I'm carrying at this point a 30% contingency, which is appropriate to carry when you start design. That contingency, which is about $2.2 million, that will get reduced when you head into construction to 5%. So that is to account for, oh, I got to take the roof off and replace those filters, that kind of thing. Like those are the things that you find in design that you're like, okay, we really need to do that. So that's your buffer. That 2.2 is your buffer. That might go down. We want it to go down. We're hoping it goes down. Okay. And then we factor into our engineering. We've already had a few contracts signed with you. Final design is step 2. Bid construction administration. So initially you said, who's going to watch construction? We would watch construction. We would bring you the whole way through. We are your advocate. We are your eyes. We are making sure the contractor is building it according to our specs and plans. And then there's a token amount for any legal and permitting that the town might need to do at the bottom. So that's contract 1. About, let's call it 12.6 at bid date. Okay. Contract 2. You can go to the next slide. Contract 2, this is the remainder of the plant. I've explained what all those different multipliers are. There's still a contingency. And I forgot to upgrade. Oh, this is escalated. That's a typo. And we had already sent you the slides before I could fix this. Those are being escalated to 2029. April, not 2027. Those should be 2029. Okay. And
Are the
so,
amounts right or no?
yeah, the amounts are right.
Okay.
The amounts are right. It's just that. So we're looking at about a $7.6 million contract 2.
So those numbers are correct?
Mhm.
Okay, so.
Just the date.
It's just the date's wrong. It should be
Okay.
April 2029.
Gotcha.
It should be April
That's
2029.
That's on this slide.
All right. So, you can go to the next slide. That, we'll pause here and I'm going to turn it over. Aiden, if he's still there, I'm going to turn it over to Aiden next. But that is what we came up with to kind of come back. How could we reduce this cost? How could we look at what Steve could do? How could we phase the project? And that is what I presented in the chapter 5, 6, no, 5, chapter 5 of the PER that Josh sent out to you guys. It's kind of it's a phased approach. And I think one of the goals of tonight's meeting, and it is to leave with an approval to move forward and finalize the PER.
So we need to make a motion, right?
That would be best. If it's the role of the board.
With that kind of phased approach, the approach that we've
Okay,
put forward.
you want me, I'll pull it up and say the words.
Because this is really, I mean, we've been looking at this for quite a while now. We just fine tuned it, so. Would somebody like to make a motion to accept the study?
I just have to read the sentence that Josh sent us. I was unprepared.
Very complicated.
Well, I'm gonna make sure we say it right. A memo.
Move to accept the preliminary report for the wastewater treatment facility 20-year study.
So moved.
Thank you, Aaron. Any further discussion?
Did Aaron
So-
second?
Yeah.
David did.
I did second.
Oh, I thought I moved it.
No further
While you
discussion.
were
Okay.
trying to,
Or I'll second.
there we go.
All
Okay.
right. Dave made the-
I was still trying to find the memo.
I
Okay,
don't think you
further
did.
discussion and further discussion, please state your name and your vote.
Aaron, I.
David, I
Morgan, I passes.
say the
Thank you.
agenda, but not.
Okay, so my next step is to, basically what I submitted was like about it was, I'm calling it 90%. There's one thing, Lynette, I need to do for you, and that's the priority list application, priority points. I will get that into the report. I can put a bow on it and submit it to the state. for
Yeah, do you
approval.
wanna do a call on that, before you submit it?
Yes, I do.
That'd be great,
I'll arrange that with you. Thank you, Lynette.
thank you.
And so that takes care of the wastewater treatment facility. I'm gonna sit here while Aiden presents, but now we're gonna move into the loan payback alternatives. Do we need to take a break or is everyone
When can
good?
we go to bid?
Here we go, it's like 5 hours.
April, we need to approve us designing.
I was on this for an hour and a half.
April 27th.
That was a while ago.
I don't know, anybody need a break, or are we good to?
Good to move. on.
That's
I
waitress,
actually
I'm good.
apologize, I have one question.
Yeah,
On the dewatering, half the cost was for just a building? Is that right?
The building has to be expanded.
yeah,
Right.
And we really don't have, and part of that is we've got to change that day tank.
Yeah.
So we're gonna end up having to take one side of the building off anyway, and we should expand it at that
yeah,
point.
the control room, like where the control panels are isn't big enough.
Yeah.
Like there's a
the
lot of.
electrical
code
room in the back.
issues that-
Okay,
We would have had the new control panel in, but it won't fit. We've had to remodify it to make it fit into what we have.
so,
And
okay,
it's not ideal anyway, but it's tight and not well
you
ventilated.
need the space?
Yeah. So it is a pretty much a whole new building there.
Great.
Yeah.
Great, thank you.
Okay. So I'm just gonna sit here while Aiden does the next part. Okay,
right.
you're on.
Hi, everyone. I'm Aiden. I have presented a couple times earlier in the summer on the septic receiving alternatives. So I'm going to get into the loan payback alternatives. There has been quite a bit of discussion over the last probably 3 or 4 months, including some smaller group meetings on specifics of these methods. So we've come up with a handful of alternative structures that I basically have results ready to present on, and we had also provided the tool that we had used to generate this. You can click to the next slide. Okay. To reiterate from Kirsten's part of the presentation, this was using the phased contract approach. So 2 different CW, oh, that is a typo, CWSRF loans. They are expected to be approximately $12.6 million and $7.6 million respectively. So basically, in order to pay for the loan, there will need to be increased revenue generation. This is the reality of any significant bond. It's a significant amount to have to pay back. Currently, Richmond is primarily generating revenue from sewer fees, both fixed and usage fees, as well as septic receiving fees, which was the basis of a lot of the discussion earlier in the summer. So we had detailed, I mentioned before, we had some working group meetings. Those were both in August to go over possible loan payback alternatives and different avenues that we could look at to repay those. That included various projections for developments, for septage rates, for sewer rates, for septage receiving volumes, and I'll get into that in a little bit more detail right after this slide. I do have some overarching notes that I wanted to add as well. So for both of these loans, we would anticipate 30 years. That would be both construction and engineering. When I had last presented, we had believed that the engineering loans were only on a 15-year timeline, and the construction was for 30 years. We have since learned that that is only if construction does not move forward. So the reality is those will actually be packaged together into one 30-year loan, which actually reduces the principal a small amount, especially during the peak years, which will be helpful. Additionally, there is I believe it's currently $1.35 million congressionally directed spending grant that's under final review. So we're not currently incorporating that into any of the repayment structures. Were that to go through, that would improve basically the outlook for the town and reduce slightly how much user rates and or septage rates would need to increase in order to cover the increased loan repayment costs. Let's see. So one of the big things that we found with all of these, and again, I'm going to go through the 5 different alternatives individually, but when you are starting the loan repayment period, you're going to be seeing significantly increased annual expenses in the short term before you've had a chance to really ramp up your revenue generation. So before you've increased sewer rates or septage rates accordingly. And that's basically just because you're going to be looking at an equivalent principal payment over the entire 30 years of that loan. So you will have a significant expense that you need to pay in year 1 of the loan repayment period before you may have built up significant financial reserves or before you've increased septage or sewer user rates adequately to cover that. So that's a big challenge that we've seen with all of these different analyses that we've done. So that's kind of why we're varying these different alternatives. We're trying to present you options that are feasible for the town and could be approved by the town in order to adequately repay this project loan. You can click to the next slide. Okay, so this is the first alternative. I'm also going to add, I know that during the working group meetings, we had kind of dove into the actual structure of the tool that we use to generate this. That is something that I can do at the end of the call if people would like to explore that a little bit further. But basically, the tool just projects forward revenues and expenses with consideration to all of the septage upgrades that were planned in order to basically allow you to enter septage rate increases, sewer rate increases. You can vary the loan itself. When you start it, there are loan suppression tools you can incorporate. You can modify the grant or subsidy funding, so that would include the congressionally directed spending grant. So these are all in the tool that we sent 5 different alternatives for. So this is something that you can continue to vary as we go. So each of these alternatives is just based on a structure that we had agreed upon in an earlier meeting as being sort of a starting point. But you can sort of mix and match from each of them as you go, as desired, to come up with a structure that you think makes sense for the town. So for the first alternative, this was intended to maintain the septage receiving and increased rates. So in recent years, the plant has received approximately 20,000 gallons per day of septage. So rather than projecting an increased volume, though the plant will have capacity to accept increased volume, for this alternative, we maintained the recently received volume of approximately 20,000 gallons per day. And we also tried to minimize sewer rate increases. So making up the lost or the missing revenue or the excess revenue that was needed for this scenario, we primarily increased the septage receiving rates. So we we detailed what we incorporated for those rates under model inputs. So for the septage rate increases, you can see I just mentioned that grace period, but we need to increase the rates a little bit more in the initial years in order to make up for basically the increased expenses that won't be able to initially be covered by your annual revenues. One thing that Richmond's done a really good job of is building up some sewer reserves. So some financial reserves that you can draw on to help dampen the blow of initially paying for these increased expenses at the beginning of the loan repayment period. So you can see that we start with a relatively large jump in that first year of approximately 25%, slightly reducing after that, 20% in year two, 10% for the next 2 years, and then 5% for the 2 years following that. And then I state matching inflation after FY31. So from those initial years that I stated on, we would basically be just matching the projected inflation rate of, I believe we use 3.5%, which is a little bit conservative, but is relatively representative of recent years. So the assumption would be that septage and sewer rates do increase relative to inflation after those initial bump years. We also projected expenses increasing proportionately as well. The sewer rate increases for this alternative, I had mentioned we were trying to minimize the sewer rate increases, so we did a 10% bump just in that first year. And then beyond that first year after FY26, you would just be matching inflation, so at that 3.5% number. You can click to the next slide.
Actually, I
I
got,
have a, yeah, thank you first.
the 20% FY27, is that 20% over the FY26 rates, which are 25% over FY25?
Yes.
Okay.
Yep. So that's
That was
basically
my
like
question too.
That.
it may be beneficial too. I don't want to click away from the slide, but after we looked at these, I'd be very happy to pull up the tool and just kind of show you how the inputs work. I know that we've presented it to some of you already, and we did provide the tool as well. So that's something that on your own you can certainly play around with if you want to, see what happens from varying this input or varying that input. But I'm very happy to pull that up and just show you kind of how it works after the presentation.
And then,
Steve, what is the current septage rate
7.5 cents
per
gallon.
gallon?
so then that 10% in FY26, that can't be right. That's the total increase to the users for the entire
For the sewer.
20-year study?
That would just be the sewer rate increase in year one. So after that first year, the sewer rate increase would be 3.5%, which is matching projected inflation.
Back to inflation.
But that plus the septage, that pays for the entire bond?
Plus the septage increases, yes.
Oh, right, yeah, but I mean,
Yeah,
10% on sewer doesn't seem terrible bad. Before we were talking like 100% increase.
Yeah, like 110%.
Yeah.
This is alternative A.
Yeah, this is alternative.
Okay,
Yeah,
well,
so-
just to make sure I was understanding it correctly, it's been a while since I dove into it, okay.
Yeah, so the septage rate increases are really doing the heavy lifting here. I think we had discussed, back in June, July, just how beneficial receiving septage really was financially. It's basically paying dividends to receive it because it generates more revenue than it really costs to process. So that's where it's doing the heavy lifting. It is a relatively sizable increase in the septage rates. And when we do click to the next slide, I did an FY35 projection, so you can see the overall increase over a 10-year span. So the top one is the top left table, the top line, I said average residential user annual bill. So there would be approximately a 37% increase over that 10-year span, whereas the septage rate would increase dramatically. So that's kind of where the difference is because, we're applying compounding increasing factors.
Can't
So
see that.
it more than doubles in that first 10-year span. With that being said, as of right now, Richmond is one of the lowest actually rate septage receivers in the area. So there are some variables that are very difficult to anticipate, really, namely the septage receiving market. During previous discussions, Steve's indicated that there have been temporary closures of other plants where they can't receive septage because maybe they're at capacity or something to do with where the septage haulers want to take the septage. So there is a variable here. This basically, for the first one, assumes that Richmond continues to receive as much septage as they have in recent years. It's certainly possible that Richmond could receive more, or that they could, you could receive less. But that's basically the assumption for this first one. So the top right figure shows you the rate increases. So the blue line is the average residential user annual bill. So you can see that's steadily climbing, a little bit of a bump in the first year, and then a more gradual 3.5% increase per year. The septage rate line is in orange. That's quite a bit more significant. And that's actually corresponding to the right axis, the right y-axis. So that one increases quite a bit more dramatically, especially in those earlier years. And then if you look down at that bottom figure, that is basically representing the projected value of Richmond sewer funds for the entire duration of that 30-year period. I don't know exactly how big your screen is there or if you can read what the numbers are. To be honest, the specific numbers are in the long term, requiring a lot of assumptions. That's a very long-term projection. But really what we're trying to look at is we want to keep that number above zero for the entire duration. The intent of that is, that way it's going to simplify everything financially on your end. We want to make sure that you can generate enough revenue in addition to the sewer reserves that you have available to stay in the black. So that's really the big thing we're looking for when we're varying all of these input parameters is we want to say, okay, like we can keep that number above zero. This will be beneficial for the town. This would be a viable payback structure for you to be able to pay off the loan. So, we are looking at, you can see a couple little bumps in the initial period. FY 28 is when we had contract 1 starting, and then I believe it was FY 32 for contract 2. So you can see that there's an initial little drop, and then after FY 28, FY 29 is not increasing the same way, same with FY 30. You're starting to gain revenue again, and then FY 32, that second contract hits. So then you start to see the dip again. Throughout all of this, you're continuing to increase your sewer rates and your septage rates by the same as the inflation. So that's not a significant number. That's only 3.5%. However, your principal payment on the loan is not going to change. So what you're really doing is you're weathering the storm in the initial years where you don't necessarily, you're not necessarily starting with enough annual revenue to make the annual payments. But as you increase gradually, eventually you'll outpace inflation where that loan repayment becomes significantly easier for you to make. So for all of these, we're going to see that little dip in the middle. I call them the lean years, I guess, sort of in the FY 30s. Okay, so that was a lot of overview. That's alternative A. You can click to the next slide. A lot of that's going to inform all 5 of these alternatives, just kind of generally what we're looking at here.
Okay, I wanted to one
Sure.
comment. Go back to that slide. So all the way to the right, if I understand this, that's going to be a buildup of cash for the next 20 years, so to speak.
It would be, yeah. So
I mean, it's one way of thinking about it.
one significant comment that I would have is that beyond probably 20 years, there's a lot that's really requiring long-term projections that there are a lot of unknowns that are not really plannable for. So, you may have other significant capital projects that aren't currently projected. We do have I don't want to call it a token amount. I looked at some of your recent years to project an estimated annual value of capital expenses outside of this, and then we're basically inflating that. We're applying the inflation factor to that so that there is some additional capital cost coming out, but especially in that 20-year time frame, you might be having other significant projects that would be pulling from this money. So there's a reason that the number keeps going up, and it's because it's difficult to anticipate when and how much any other really significant capital projects might need to occur.
Thank you. I'm sorry.
The average residential user annual bill, is that just for the like for the?
That's the sewer rate.
That does not include their
Doesn't
water.
include water.
Yes.
But this
It
would,
seemed low, that's why I
but it
was.
wouldn't affect.
But if it was,
Yeah.
well, I know, but it just, when I was combining like what the bill, in my head, I was like, this must just be.
And I can I don't
Are
know
you
if I
guys
have
here
it.
for the water and sewer meeting?
The last item.
You are? Okay. I was excited. We don't usually get visitors.
You may not want us.
Okay.
Okay, I'll continue with alternative B now. And please feel free to continue jumping in if you have questions as I go. You're welcome to do that. So alternative B, this is sort of the best case scenario, like the ideal alternative. The biggest difference between this one and alternative A is that we're actually increasing that septage receiving volume. So this kind of gets into all of the exploration earlier in the summer where we were saying, okay, well, the outlook is significantly better if you are receiving more septage volume. The plant will have capacity to accept more. It is a revenue generator for you. The revenue exceeds the added expense. So similar to the last one, you don't control the market. It's difficult to anticipate exactly how much septage you will have capacity to receive. This is within a reasonable range of volumes for you to receive for what the plant can handle, but there are unknowns surrounding whether haulers will actually be bringing this much septage to Richmond every day. So we increased that value. Similar to the first one, we were trying to minimize sewer rate increases and really make up the difference in revenue generation with the septage receiving rates. So for the model inputs, I'm actually going to jump to B first. We didn't incorporate any jumps in the sewer rate increases. We basically just matched inflation throughout the duration of the loan repayment period. And for the septage rates, they are significantly smaller, the increases, than they were in alternative A. We only did 10% in the first year and then 5% for 3 years following that, and then matched the inflation rate beyond that point. You can click to the next slide.
When we say gallons per day, gallons per business week days or 365 days?
Good question. So it's 50,000 gallons per business weekday for the projection. So that's 36,000 gallons per day, accounting for 7 days of the week. So that's the total average for the whole year.
Okay.
You can go to the next slide.
Steve, where are we at right now about per day on average in a year?
20,000, you said, right?
Septage, right around 20.
Per day for 365?
I think we're around 25, but
And that's
Um,
that's per 365 days.
yeah.
So this would be 10,000 more gallons.
It-
Yeah, that would be my one concern is that are we gonna get it's not like we're turning haulers away now. So it wouldn't really increase the.
No, we're gonna, to increase, we're gonna have to really make it desirable to come to Richmond.
10% off your wedding at the press.
Yeah, part of that is, if we can go to 24-hour receiving.
Oh, okay, so there are some ways to increase volume maybe.
There's a considerable market out there that we can't get because we don't receive 24 hours a day.
Okay, that's good to know.
The 36,000 is totally doable. Monday, we took 41, today we took 51. I mean, it's totally doable in a day. It's not like the plant can't
Yeah.
handle it.
I'm sure the plant can handle it, especially with the upgrade. I just want to make sure that the volume of demand is there. over the year.
I think the 24-hour receiving is what we're missing a little. I mean, Shelburne takes it 24 hours. Montpelier, I believe, does. And there are haulers out there. I mean, P&P has started to ask more for Saturdays.
Okay.
They've been averaging probably, I mean, a couple of Saturdays, they brought 13,000 into us. Just because they have 30,000 gallon storage tank that they can store it on site, but they, in a pinch, if that's full on a Friday, then they don't have anything, they have a big issue. They don't have any place for it to go, so.
Okay, so it sounds like there's potential for that much demand.
I think there is, and I think we just have to go out there to get it.
Yes.
As somebody who was water and sewer commissioner when I was on the select board 25 years ago. One of the concerns was when we started really increasing, using septic as a moneymaker, was the neighborhood. And I think you have to really think twice about sending trucks down there at night. Maybe there's an alternate way to get it there, but that was a concern, 25 years ago. The neighborhood with the big trucks going down and the noise that they created.
It's a very good point.
All right. So are you ready for the next slide, Aiden?
Sure.
You were
Yeah.
ready a while ago.
Okay, so this is an equivalent to the slide I'd shown for alternative A. Top left, that table is showing sort of that 10-year increase. We're still seeing, a larger increase for the septage rates, but significantly less than for alternative A. It looks like about 57% for those first 10 years. And then the residential user bill would go up 28%. I want to clarify that is just 10 years worth of 3.5% inflation. So that would be I don't want to treat it like there's no increase, there is, but it would be assumed that it would be matching inflation. Whether that would actually happen on an annual basis or more sporadically I'm not sure of, but that was the assumption for this alternative. So top right, you can see the projection for that first 10-year period of the rate increases. Again, blue is the sewer user bill, which again, that's just reflective of the rate increase. So for this, those are, that's the same as like the fixed rate are, the fixed rates are increasing at that rate. The usage rates are increasing at that rate. Basically, all of the user rates are increasing at the same proportional rate. So you can see the septage rate jumps a little bit more right at that beginning stage, and then it continues to increase a little bit more gradually after the first, I believe it's 4 years. But this is quite a bit less significant as compared to that first one. So this would be an added benefit were this to happen to continue to attract septage haulers, because you would not necessarily need to increase septage rates as much. So it would maintain Richmond perhaps as one of the lower or lowest cost septage receivers, certainly high volume septage receivers. So going back to that bottom table or the bottom figure, this is the exact same thing as the last one. What we're really looking for is, we want to keep that bottom line in those lean years in the FY30s above zero. Want to keep you in the black. So again, it's really helpful that Richmond's done a really good job of actually building some sewer reserves. We have not always seen that, and it really simplifies the types of rate increases you need to do in the short term in order to stay in the black. But very similar. I think the majority of the alternatives we're going to kind of see, it'll rise. You'll hit FY28, the rate of increase will slow down a little bit. You'll hit FY32, and all of a sudden we're going to see a little bit of a dip while the revenues need to catch up to the second contract being added to your annual expenses. You can go to the next slide. So alternative C, which we had come up with during the previous workshops, incorporates 10% taxpayer burden sharing. So for this alternative, this does assume continuing the recently received volume of approximately 20,000 gallons per day of septage, maintaining septage receiving rates, doing sewer rate increases primarily to make up for that lost revenue, as opposed to the septage rate increases. And then there is a 10% taxpayer burden sharing. This is something that we are well aware may not be, necessarily viable or may not be viable, at the base level for every client. But basically, this would include all taxpayers, not just the ratepayers, taking 10% of that principal cost on the total loan, and then having that be part of the general tax rate. I think we had previously discussed, that this may not be viable, but ways that it perhaps could be viable are favorable contracts for Richmond residents with septage haulers. So those residents who are on septage as opposed to sewer perhaps would get basically a reduced rate on paying to get the septage pumped out. So that is something that may make it more feasible, but at least for the purposes of this analysis, that was the assumption. So basically, the model inputs I had mentioned before, this would not increase the septage rates. So that would just be matching the inflation of the 3.5% per year. And the sewer rate increases, this is now doing the legwork for this alternative. So you can see we have significantly larger increases. 25% the first year, 20% after that, and then 15, 10 for a couple years, 8 for a year, and then 5 for 3 years at the end. So we're kind of trying to front load it as best we can for the projections, with the understanding that it is still quite a significant increase. But basically, the goal again is keep the value of the sewer general fund, the sewer funds, excuse me, in the black for the entire duration. So without septage rate increases and without septage volume increases and with 10% taxpayer burden sharing, that is roughly what we were looking at in order to stay in the black. So you can click to the next slide. So you can see a significantly different increase compared to the first two alternatives. So the top left table is showing, again, the residential user bill for that first 10-year period and the septage rate. So looking at just the smaller increases for septage rate, that's only 41% over the 10 years, but all of a sudden the residential user annual bill has jumped up significantly more than in the first two alternatives. That would rise about 167%. For the 10-year span. So that is reflected in the figure to the right, which is showing, again in blue, that is basically the sewer rates, but we're depicting it as average residential users rate, annual payment, and then the septage rate in orange. So we can see that's steady, it's not climbing quickly, it's just maintained inflation rate throughout the duration. But then the residential user sewer rate bill basically climbs significantly faster due to the way that the revenue is being generated for this particular alternative. And then again, you can look at that bottom figure. I'm going to be kind of a broken record on this. Most of them look pretty similar, but we're really just trying to keep it in the black as best we can. So for this one, where we were just using really the user rate revenue generation to make up for that that extra revenue needed for the loan repayment, it's pretty much the exact same pattern. You see a little bit of a blip in FY28, another blip in FY32, some lean years in the middle while you're still kind of catching up on your revenue generation, and then you'll start to accumulate more and more once that revenue generation starts to exceed the annual principal payment on the treatment facility bond loan. So you can go to the next slide. This one is the exact same as the last one, except at 20% taxpayer burden sharing instead of 10%. So just to reiterate, that's basically the exact same thing. It's just that 20% of the principal on the loan would be divided between the full tax base for the general tax rate as opposed to specifically sewer user rates. So similar to the last one, matching inflation for the septage rate. The sewer rate increases are more significant than alternatives A and B, significantly more so, where we were not really increasing those, but this is reduced relative to alternative C, where we were looking at 10% taxpayer burden sharing. And that makes sense. We're basically taking an additional 10% out of the revenue that needs to be generated by ratepayers for this alternative specifically. So we're looking at 25%, then 20%, 15, 10, and then a few years of 5% in the FY30 to FY32 period. You can go to the next slide. So this looks similar to the last one. Really, the big difference is the residential user annual bill. So at the last alternative C, we were looking at 167% for the 10-year period. This is 137. And then the top right, you can see the depiction of that graph, or on the graph. Similar to the last one, the orange is a pretty steady climb, but blue is increasing a little bit more in the earlier years, but it does not peak as high as for alternative C. So it stays a little bit lower than that one. And then back to the bottom figure, again, just trying to keep everything in the black. So FY32 is when you'll start to see the blip from that second contract coming in. You can go to the next slide. All right, so alternative E is actually the one that we were most excited about. This is something that we've only learned about relatively recently, but basically the Vermont Bond Bank will allow CWSRF loans to be suppressed for up to 100% for the first 5 years. Basically, the way that this works is you still need to pay the administration fee annually, but you can suppress by, anywhere from 10 to 100% how much you are paying from the principal in those up to 5 year or first 5 years. So basically, when you are suppressing that principal, you still owe the full amount of principal, and then that amount is basically slightly increased because you're paying it over a shorter time frame. So let's say you suppress your loan for 100% for the first 5 years. The full amount of principal that you would have paid in that first 5 years gets distributed evenly across the remaining 25 years in the loan. So the result is you have an increased principal payment starting after 5 years, which sounds counterintuitive, but it actually it really helps in that you can slightly more conservatively build your sewer reserves, and you can slightly more conservatively increase your revenue generators, so septage or sewer rates, in order to kind of get a little bit of a head start before those loan payments kick in. So we found that this is actually really helpful for pretty much all of these scenarios. So for this particular scenario, we did 100% loan suppression for 5 years on contract 1 and 50% loan suppression for 5 years on contract 2. And then similar to the last one, the difference is primarily being made up in sewer rate increases for this alternative. So for the model inputs, again, we matched inflation on septage rates, and then sewer rates, we distributed it significantly more. So it's basically 10% per year for approximately 10 years on sewer rates, and then inflation or matching inflation after that. But there weren't any of the really significant single year jumps the way that we were seeing in some of the other alternatives. You can go to the next slide. Okay, so similar to the others, you can see, so we do still have a relatively significant increase on the residential user annual bill. With that being said, this assumes no larger bumps in septage rates, so that's just matching inflation. We're making up all of that lost revenue with the sewer rates. So this is lower than alternative A. I believe it's A. I would have to double check that. But if you look at the figure on the top right, you can see basically the residential bills for the users are increasing, so sewer rates are increasing slightly differently from the other years because we're looking at that steady 10% increase as opposed to larger jumps in the first couple of years and then leveling off a little bit. And this is basically just enabled by the loan suppression method. The big difference is, and this is really the only graph that looks significantly different from the others, the bottom section, you can see that you generate significantly more revenue in those first years. Like you can actually build up your reserves utilizing this method. The total amount on the right side is not as high as the others. However, it kind of offsets those lean years. It'll push them a little bit later, but it allows you to build more reserves before you have significant financial obligations, significant expenses from that loan repayment because you don't need to pay it right away. So even though you're increasing your later annual principal payments, you're allowing yourself time to save money and to more gradually increase user rates to hopefully minimize the burden as best as you can on your user rate paying base. Okay, so that's the end of the alternatives. If you go to the next slide, we have conclusions, or I can take a question right now if you have one.
Yeah, good.
This suppression alternative E, could you increase the septage rate
That was my,
by percentages
my question.
so that it
So
wasn't
Aiden-
on the U?
I think let's just back up. I mean,
How does,
Hey, Steve, Steve,
Right, kind of.
I think what he's done, these are just 5 like snapshots.
Mhm.
So we can take any of these and just move them around. And
Okay,
I think that's what is going to require in more meetings for us to
Okay.
start playing with that.
But yes, it is a possibility.
Yeah,
Okay.
because my thought was the same with alternative A, we increase, septic receiving volume stays the same, rates go up. But user rates only go up 10% 1 year, and then it's inflation after that.
Mhm.
So if we could combine A with E, somehow we
Mhm.
might be able to flatten user rates
Well-
and increase septic rates, but not as much.
Right.
That might be
I was looking at B.
the increase septic, the amount of septic.
Increase septic volume and the rate.
Mhm.
But if we go with A and you increase the volume, you'll be making more money and then you can not have to count on that.
I think,
There's a fine line on what we can charge and the ability to increase the volume.
Well, and I think also being sensitive to people that live in the town that have to
Yeah.
pay rates. So there's, I mean, that's why he's put out 5 or 6 different parameters of potential revenue generation. And we just have to have conversations with the community at large, people outside.
I mean, I would like to see an E alternative with increased septic rates and see
Yeah.
what it would do.
I also
With
think
with the ability to reduce the individual sewer users' rates.
I think Fran is a good point too, additional traffic on Esplanade, we should make sure we keep that.
Right.
Yeah.
Yeah.
That's good.
Because that option A, I feel like it only went up to like $700 or $800 in the FY35 value for the
Right,
Yeah.
users. So how do we keep that not
yeah.
as high?
Let's see what its conclusions
But anyway,
are.
we'll keep talking about
All right,
that. Thank you,
great.
Aiden.
Yeah, this is good.
So that's the intent of providing the tool as well. So we have the base spreadsheet that doesn't really have any specific inputs. We might have played around with stuff, but the other 5 alternatives, we provided the actual tool that has those inputs in it. So you can play around with it as much as you want. We wanted this to be something that ultimately we don't want to be bringing this to the meeting and saying, oh, these are your only options. We want you to
Right.
be able to mix and match from different alternatives and say, hey, this works really well for suppressing those first couple years. So we can be a little bit more conservative on bumping up sewer rates, or maybe this allows us to respond to changes in the septic market and we can bump that a little bit more conservatively. So yeah, that's the entire intent of the tool. I believe we already delivered that as well, but I'm very happy to look at that with you, whatever's necessary to help out. I'm going to quickly do these conclusions and findings. I think I'm also now pushing on my time. I have a couple more slides after this as well that I'm hoping I can cover quickly. But I'll start with this, and feel free again to jump in if you have any questions as I go. So the conclusions, we've kind of sort of discussed this just in the overarching discussion, but the ideal scenario is alternative B. Basically, this would require minimal rate increases. There is more risk around this alternative though, just because of the volatility and the uncertainty with the septic receiving market. Basically, there are factors that you can't control, that we can't control. So there is some risk in assuming that will be a viable approach. In all of the other scenarios, the sewer rates, the septic rates, or both are going to have to increase a little bit more significantly, at least in those initial years, in order to cover the initial loan payments. I think as we all saw, septic rate increases get you a little bit more bang for your buck as far as how much additional revenue they generate relative to what the actual increase is. However, the fact that you do need to, or you would want to maintain Richmond as an attractive location, a destination for septic haulers, plays in as well, where again, there's a lot of unpredictability. So the alternatives C, D, and E, the taxpayer burden sharing and the loan suppression, they both would reduce the needed rate increases. However, similar to the others, there are outside factors that will dictate their feasibility. And then the bottom bit is just talking about how the tool that was generated specifically for Richmond and then provided, we're kind of expecting this to be a living tool. Like things are going to change over time. It's really difficult to project all of this stuff. Maybe there's something that nobody sees coming that happens in 7 years. So the intent of the tool is you can use it and modify it in order to respond to unexpected findings, to respond to the septic receiving market you know, having a dramatic change, or maybe Richmond becomes the primary receiver in the area. You know, there are enough unknowns that providing you the tool hopefully will allow you to continue to use it over time to respond to things that are happening. So you can click to the next slide. I don't know if anyone had final comments on that. So this is a separate, like, this is related to the loan payback items. However, it doesn't tie into the alternatives that we generated. So it's a little bit different. So if anyone had additional comments on the previous section, this might be the time to ask them before I get into the Whisper program.
Sure.
Can
I'm sorry,
ahead.
go ahead. Get their hand up.
Sorry, I don't have a hand raise option. I was hoping to schedule a call with you, Aiden, to go through your assumptions,
Sure.
if that's okay.
Yeah, of course. Would you like me to send you an email with possible times?
Yeah. Tomorrow afternoon after 2 is good.
Okay. Just give me 1 second to check my schedule.
Why don't we do that afterwards? Just.
Yep.
I could do 3 o'clock.
All right, send an invite.
Okay, sounds good. I will. All right. Did anyone else have additional questions?
So, yeah, this is more, maybe it's a comment or question. As we go out to try to figure out the revenue generating, looking at the potential sources of revenue, are there legal guardrails that we need to consider that you've ever run into?
Lynette, feel free to chime in. I think I think the towns, this board has been delegated the authority to set user rates within your town. So I think you have that authority. It is in your sewer ordinance. And it is basically up to you. That is your authority.
Right. Okay.
There
Thank
used to be statutory language related to receiving grants for this type of infrastructure, but it's since been repealed.
Okay. Yeah, I was thinking of, in the line of, I have to go back and read them, but if we are asking for entity A to share a larger burden, then maybe other, you know, is there legal limits to what we could push on that, or?
You mean between the users and the town, the general? Again, I think you as a board have that authority. And I mean, it's been delegated to you in your bylaws, so I think it rests with you.
Okay.
You might want to talk to your legal
Right.
to know that for sure, but I'm assuming that is all codified in your bylaws.
Right. Okay. Thank you.
And Fran,
I'm sorry.
Fran Thomas, I probably disagree on that. Why, like, you can't go out and ask me. You do not have the authority to come out and tax me for the water and sewer. It has to be
A bond vote.
vote of town
Yes.
residents.
That's what I meant. Like, it is something that they would propose that would then get voted on by the town.
Okay, thank you.
It is a little yeah, because its taxes and bonds are separate from user rates, because user rates, you're right, are totally set by the commission. But taxes, yeah, that's.
So there's some
Yeah. Yeah, okay. Should we move on to the Whisper?
Yep.
All right, so I'm going to very quickly run through this. I will try to go fast to leave Eric enough time for the pump station presentation. So the Whisper program, I believe Josh was reached out to by the town of Waterbury. about asking basically whether this project could act as a sponsor for a floodplain restoration project. So basically, I believe the way that the Whisper program works is that it's intended for supporting natural resource projects within Vermont, and basically, um, sorry, I'm trying to verbalize this. Larger projects of very specific types, including wastewater treatment facility upgrades, can sponsor natural resource projects, which have up to 10% of the principal cost, or which cost up to 10% of the principal cost for the sponsoring project. So basically, the way that this works is that the sponsorship, so the sponsored project, which would not be Richmond's treatment facility. For this example, it would be Waterbury's floodplain restoration project. The cost of that project would be added to the principal of Richmond's loan repayment project. Then Waterbury would receive the cost of their project effectively as grant dollars, and the incentive for Richmond to become the sponsor of a project for a different town would be that you get a reduced admin rate on your construction loan. So I believe that it is a 2% administration rate typically, and the way that that works is it's 2% for the entire duration of the loan. So whatever that total interest payment will be divided equally between the 30 years of the loan. So the administration rate, the amount that you're paying for that to the loan would be reduced by sponsoring the project. So ultimately, you are getting the full sponsored project cost in reduced annual payments. And on top of that, there's an additional 0.1% reduction in the administration payments you need to make. So basically, it would provide Richmond financial incentive to sponsor Waterbury's project, while Richmond would actually have savings over the course of the loan. So this figure probably will demonstrate it a little bit better than I can describe it. But basically, you have two different bars on this bar graph. The blue is the principal on the loan, and then the gray is the administration rate total. So basically, you are seeing savings because you have a reduced administration rate. And actually, if you could go to the next slide, that might demonstrate this a little bit better. Okay, so this is showing you the contract. So this is just for contract one. We have the base loan. 10% would be the maximum project cost for a project that this project could sponsor, that Richmond could sponsor. So combined, that would come out to about $13.8 million, up from the roughly 12.6 for the base rate. That would reduce your admin rate from 2% to 1.22%. And then the very right column displays basically how much would be paid over both of those loans. So for the base loan, where you're not sponsoring a project and you have a 2% admin rate, the total payment would be about $16.85 million. Whereas the combined loan, where it's a higher principal but a lower administration rate, you are actually spending about $243,000 less over the life of the loan. I don't know, I don't know specifics of basically whether you would necessarily want to implement this. I would imagine this is something that the sewer commission would need to discuss on the side. But this was something that I believe Josh had asked us to look into. And I think the bottom line is it would save you money over the course of the loan. Additionally, it would allow Waterbury, which is, a nearby community, to do a water quality improvement project to basically, preserve the environment. So I think the intent of the program is basically to incentivize towns doing larger projects to sponsor some of the smaller projects and kind of present a win-win situation for everyone. I don't know. I believe that's pretty much the bottom line there. I'm not sure exactly how much further we discuss that during this meeting. It's also
I
possible.
think we just present it. It's kind of a convoluted idea, but again, it's nothing that you need to commit to until later. It's another form, it's another way to have some savings on your loan repayment. I mean,
Yeah,
a quarter
you
of a
wouldn't
million
need to-
dollars is nothing to sneeze at, so.
You would not need to commit until the step 3 loan is submitted. So yeah, that was another note.
I can
So-
answer some questions if you need me to, or if the committee would like a separate meeting with Catherine, who runs our Whisper program. I can help set that up.
I think in the interest of time, we probably don't want to ask too many questions
On
tonight,
this.
right? But I do have questions, but it seems like we have to probably keep going.
Yeah, I think like to Morgan's point, we might need to come back and talk about all the funding options. At another meeting.
Yeah.
Sure. So Lynette, I would reach out to you or Catherine from Whisper.
Yeah, Catherine King.
Yeah, and maybe one of them could come and help explain a little bit more because $250,000 could be a nice savings.
Yeah,
It's, yeah, probably warrants a little bit more digging into.
it's not something that Hoyle Tanner would have to be involved in.
No,
It would be a totally separate project that Waterbury is doing on their own with their own engineering construction. It's just basically the money would go over there, we get a reduction on the interest rate and save some money.
Right. Okay,
there's one more slide here, but you know what? I'd like to, it's like next steps and schedule. Let's do the pump station and then maybe, Josh, we can come back to that very last slide on this presentation.
I have one question for you while we're switching over.
Yep.
The 20-year upgrade that we're doing will last for 20 years, but we're gonna pay for it for 30?
I know, that doesn't seem right.
No, I just was making sure.
Yeah.
I didn't know if maybe we were getting 30 out of this one.
Well, where are we at now? We're at 25 years, right?
Yeah.
We're at 25 years now, so.
But the state mandates a 20-year study, doesn't it?
Yeah, the state mandates, I mean. Concrete will last you a long time.
Yeah.
I mean, you've seen the plant, it's a harsh environment, things break down.
Yeah.
And honestly, by bolstering and building up your reserves, you can continue to do equipment replacements as
Like we
they're.
talked
I-
about earlier,
yeah.
Like I told you,
Yeah.
the philosophy at the plant from the operators are next time we have a 20-year study, they come in and they're like, wow,
We did that. Yeah.
we did this, we did that. Oh, we can make this better now. We can spend some money and get more efficient, but not anywhere near what we're spending now.
Yeah,
That's the goal.
I have a.
And that's the philosophy and Brad and Mike and Aaron all bring to the plant.
Thank you, Aiden. Appreciate it. We'll come back to the last slide here, towards the end. So, last item on the agenda, tonight is the review of the 60% preliminary engineering report for flood mitigation of the pump station and force main on the other side of the bridge.
Right. Just a little bit of a mouthful. Yeah. My name is Eric Doe. I'm engineer with Hoyle Tanner, been leading the project, as Morgan said. This started as mostly looking at the pump station and the force main, but we've also tried to pull in other parts of the infrastructure, the collection system that are subject to some of the flooding that occurs in town too. So you'll see. Could you go to the next slide for me?
And if I could just, I'll add that Steve, maybe Steve, is like the floods, the pump station over there has been flooded 2 or 3 times the past 5 years. 3 times and has failed. And so this is a need to raise this station, or we continue to go through this.
Doing my slides for me.
I'm sorry.
Yeah.
I apologize.
You've been
Well,
waiting all that time.
That's just it. The pump station is within the floodplain. It experiences the frequent flooding. There's a photo right there. Pump station is behind the green street sign on the utility pole. It's underwater. The type of pump station that it is a buried subsurface can with a hatch on top. And so once the flood comes up high enough, it's totally inaccessible. The top image there is the force main. A portion of it zoomed in. We have a better one later in the slide, but you can see rusting, some staining. There's a hole in it. it gets damaged when the flood comes through because it's where the water can get it and where stuff that comes down with the water can get it too, trees and everything else.
Which happened in the last one.
Yeah, as Steve mentioned
happened
earlier
twice.
tonight, it's happened twice and each time it's a pretty expensive repair.
Yeah.
That pump station is also about 75 years old, as I
Yeah.
understand it. It was originally manufactured for the Korean War.
That's the history of it.
It's flown around the world and I guess it's when it's way over to Korea, it came
I was
back.
told that.
Yeah, so
So it hasn't been here for 75 years. It's been in circulation. is
it's
what you're saying?
been here for about 50.
Okay.
Yeah.
I don't think it was ever actually used in Korea.
No, it
It
wasn't.
was shipped over there.
It was shipped
It never
back.
saw action in Korea. It came back.
How in the world do we know this?
Because it's surplus, war surplus.
Oh, okay.
Yes, there is some literature that remains from when it was first installed that
Okay.
says we acquired this from, forgive me, I forget the name of the camp, but
Camp Johnson.
yeah.
Okay.
And that was in the 70s, so most pump stations don't have a life like that, 75 or even 50 years old. So it's due just for that fact on its own. In addition to that, it's in floodplain. The force main I touched on, there's also sewer manholes that are in the floodplain elevation, that same FEMA floodplain, and they're just conventional manhole covers. They don't have any technology, methodologies to be watertight.
So the problem with those is the floodwater inundates them and they're not sealed, so it's infiltration into the system.
There's actually two problems. There's one manhole that is actually lower than everything else around. And that becomes a discharge point when the plant is overrun by floodwaters. Because it backs up into there and then overflows. But yes, for the most part, the rest of them become inundated with floodwaters going in.
Yeah, sometimes they seal up nicely if there's a lot of silt and sand and it gets rusted and it's not terrible. It's not like it's just an open drain hole, but it's something that floodwaters can get into. Could you go to the next slide for me? So the map here in blue is the 100-year floodplain, and a little bit tough to tell with the screen, but we're looking at the hatched area in red is the Winooski River, the road that comes down on a diagonal, that's Bridge Street. Thank you. So the wastewater plant is that little bubble that's not in the blue. So these are all the manholes that are basically right before the plant, or on the low end of town here. That's Church Street a little bit, Esplanade, Volunteers Green, and on the other side of the river, there's a couple down that way too.
Yep.
And yep, pan back over. This manufactured solution for that is a cast sewer manhole cover and frame. There's a neoprene gasket that lays in there and you can bolt it down. And so it becomes watertight. So what contractor would do when we go to, when this goes out, they would just cut the asphalt, peel that back, take the existing one off the top, go down to the block or the brick, put the new one on, repoint the mortar while they're in there, and repave around it.
No ceiling with there's
You think the whole inside ought to be?
no, they have a product now, I've seen it, that they sealed around the outsides. As
The shrink wrap type
yeah,
thing?
type thing that they use, is that not?
That would probably work. We could look into that.
I mean, it didn't seem that expensive when I was looking into some of the options out there, but it doesn't rely on the mortar making that
yeah.
steel.
Right.
It goes around that joint.
I don't know the life of that product.
Okay.
I think it's a newer
Yeah.
technology. It's basically, if you've seen shrink wrap for wiring, they slide a collar over the outside of the manhole, heat it up, and it gets a nice fit on the outside of the manhole versus the inside. So that the frame of the metal where the brick or the precast comes together, there's not really an exposed joint there.
It's just one extra step to stop stuff from getting in there.
Yeah,
I-
I would love
I-
to look into that. I
Yeah.
haven't done that on a project before.
Does this option and the shrink wrap option? These won't require you to do work in preparation for a flood. They will always be.
Yeah, they're always sealed, I
That's
assume.
right.
Shrink
Yeah.
wrap one is also always sealed.
Well,
You
the
don't
shrink
have to
wrap,
do it-
just, yeah, that's just going around where the joint's made.
Okay.
Yeah.
On the outside, so stuff can't get
Yeah.
in there.
But if you have to come in, you have to cut it
And
and
the-
then place it.
And
Okay.
the manhole covers seal with a neoprene seal.
That is just on the outside. It's
Right.
not something that if you wanted to get in, there's nothing that would be in your way.
Oh, really?
No, it just covers that joint, it goes around the outside. The manhole cover is still accessible.
Okay.
My
It's-
understanding.
It's like a cylinder or a tube that goes down over the
Okay.
outside.
How far down is that joint?
Well, we would go to the joint that we're replacing is where I
Yeah.
would assume.
They would
I mean,
probably, yeah, go
In
a
a new, I mean,
couple feet. 3
I
feet.
have seen it being used in new structures.
Really?
Over the whole structure.
Right.
Oh.
Sometimes where they have manholes that are really leaky.
They'll dig them up,
yeah.
slide that over, shrink wrap it,
Yep.
Almost
then
like a
backfill.
conduit.
That's what I
And
was
it'll-
thinking too.
It'll be up to you if you want to bolt down the covers all the time or just in advance of.
No, I mean, I think I would leave them bolted down. This is came out of going to Maine to the beaches and all the beaches up in Maine on the roads next to the beach have sealed manholes
Mhm.
to stop the floodwaters from coming into their systems. And that, I just can't see why we shouldn't do it with the, the ones that we have.
That's what you do on your vacation? Wow. Check out manhole covers?
He probably looks at.
I went to.
It's going far.
I checked out a wastewater treatment plant, so yeah.
I do the same thing. I drive around new towns and I'm like, there's the pump station. Okay, so that's the first one, the collection system, the manholes. Could you go to the next one? So here's a better photo of the force main. You can see the bridge. That upper shiny pipe is the water. Right, and then below it, on the top image, that upper pipe is the water. And below it is our existing sewer force main. And that's the one that you can tell you, it's got some staining, some water damage on there, it's discolored. It's supposed to be just as shiny as the top one. It's got an aluminum jacket on it. And it's just, it's been roughed up. The other photo on the bottom there, just showing up where a patch must have been done in the
Yep.
past.
Where the tree hit it.
Yeah.
Yep.
And the first photo, you can tell towards the left side of the image, there's some parts of the jacket or the insulation that are kind of hanging. Some of the carriers that are supporting the pipe have gotten thrown off with
Yeah.
the velocity of the water or the velocity of the tree hitting it.
It's the trees that come down.
Yeah, I think there was something hanging on it when we came
Yeah.
last year. Yeah. So we took a look, why is only the force main getting hit? Obviously, it's lower, but we found out that it's below what the FEMA floodplain elevation is.
Yep.
Now, when they build bridges, they build it to the 50-year and they add a little bit of freeboard. In the wastewater world, we like to build at least to the 100-year. So we've got the elevations on screen. The 100 is 310.3. The 500 is 313. And Sarah graciously crawled under the bridge and took some measurements for us. We think the top of pipe is around 309. So that explains why whenever it floods, it gets hit. We don't have a solution for where it ought to go, but there's probably not enough room adjacent to the water main there. Those steel I-beams that are holding it don't seem to have enough lip to put another pipe yet. Might have to come up higher.
I'm sorry.
Kevin Kittinger from Richmond. If you're only raising this pipe up to the height of the 100-year flood, and a tree comes down, does the tree always stay at the water surface level and below,
No.
or does it actually stick up higher?
Picks up.
It sticks up a bit
So
higher.
you probably need more margin than even the 100-year plain level.
Yeah, there's guidance document out there that says they want you to design to the 100-year plus 2 or 3 feet, depending on how critical the component is. And obviously it's a critical component because if the force main gets taken out, it's not something Steve can just walk over and fix that afternoon.
Does the pipe have to be under the bridge?
Doesn't have to be. That was sort of what I was just getting into. It could come around the other side. We had really preliminary conversations about this. There was some concerns that if we lift that up, maybe, I guess there's some children or folks that like to jump off the
Maybe we
river.
could just stop because it's dangerous.
Well, unless someone's good, I'm not standing out there. Tell them, yeah, I know what you mean though, but if we provided a pipe along
Well,
that railing. for
That
them-
was the thing. If we put it up, if we extended by where the water is and put the pipe there, that gives them another place to
To
go.
stand on.
To
Right,
stand on.
now they don't have to stand on the skinny little railing. They got
Yeah.
this nice wide pipe to stand on, yeah.
Or they jump and hit the pipe under.
Like
Yeah.
once-
That's great.
Yeah.
I get to see a kid jumping off the railing, landing on the spike pipe.
Yeah.
Then falling into the water.
I mean spikes, I mean little prickers.
Yeah,
Yeah,
it's still.
but still,
even
no.
I can see the kid
Could it
hitting
go
the pipe.
up like along the bridge? Is that
Potentially,
something that we would have the force to pump it that high up?
we would have to bring in V-Trans, because I think they were the ones who construct and maintain the
Yeah.
bridge.
Mm.
And make sure that everything that we would do attached to, they don't get upset. There's also a thought that we did see the plans, the V-Trans construction plans, that 2009 was the year that it was renovated, rebuilt. There might be an annular space underneath the sidewalk, which is still above where that water pipe is,
Mhm.
that satisfies the elevation that we're looking for. Still have to look into that with more certainty though. To make sure that we can go from one side to the other, right, that there's no conflicts in there. What we saw was just kind of a cross section.
One question or comment, what about a deflection plate?
That would probably be a last resort type of alternative. We'd always want to mitigate the potential damage from occurring before we would have to leave it in place and protect it. But maybe it's something that we explore if there's not a good position on here and if V-Trans doesn't like whatever we propose.
I guess I was saying in addition to maybe raising it, I don't know.
We're on the downstream side of the bridge now, which sort of helps, right? Because if the water was really high, it would hit the bridge first. But it can get sucked under and come out the other side and
Well,
stuff.
what happened last time, the tree hit the bridge and then went under. And when it went under, it came
went
up in.
Did it kick? Yeah.
Yeah, it came up in and wedged itself between the pipe and the bridge.
Yeah.
And then as soon as the water started to recede, there was this huge tree hanging on the pipe going like this.
That tree can also collect other debris and act like a big lever and
Right.
pull the pipe right off.
Yeah, when the water comes back down.
We've been seriously lucky that we haven't lost that pipe in the last 2 floods.
I can't picture what the outside of the bridge looks like well enough, but if you raise the sewer pipe above the water pipe, could you use the deflection idea of putting a shield over it so jumpers don't land on it?
Good.
Yeah.
Yeah.
See what you mean? Yeah, potentially.
Yeah.
So this is we're not as far in this design as the stuff at the plant.
Yeah.
Or at the pump station. This is the step 1, 60%, that draft that we've given over right now. We don't have all the answers. It's just more so, here's the problem, here's the typical means that we would propose, and we still need to solve some of these things by the 90 or during the final design.
I would assume that we do know that we're not putting the pipe on the other side of the bridge, correct?
I don't think it's very
No.
feasible, just given that
I
the
think
other side has the
because that's
hole
where
right
everything
there.
gets caught. That's why I was making sure.
Yeah, yeah. Well, if you lifted it high enough, you'd probably be okay, but there's not really a good avenue right there because the home is so close for us to find a way to bring that pipe over. I think there's also a concrete head wall that we would have to go over or through, but it's just a very narrow path for that force main to have to go through just to access the upstream side of the bridge.
I would just imagine things would get caught on it instantly as well.
Yeah, if the floods was ever
Yeah.
really high, that's the first thing it's gonna touch. Okay. The last item is the pump station, right? So we've identified 3 potential sites. There were more. I think we started with 5. We narrowed down the ones that were on private property. We're not gonna really consider those. Site 0, this is in the center of the screen, is where the pump station is now. Site 1 is across the street from it. And then there's also a site 5 that remains, which is at the higher end as you go up Bridge Street. Next slide. Here's some of the technical details. Right now, the pump station's doing about 9,300 gallons per day. We talked with the zoning and planning folks in Richmond, did a little bit of build out planning. We would design the new pump station to reach around 20,000 gallons per day, which would allow new developments to come in and tie in on that part of town without having to reevaluate the pump station at the time. We estimate that the new pump rate would be about 58, call it 60 gallons per minute. Right now, the station's doing about 100 gallons a minute with it's using a different technology, but if you can get apples to oranges, that's kind of what's happening. We think that with that flow and the total dynamic head needs about a 3 or 4 inch. Right now, there's a 6 inch, so maybe that pipe actually decreases in size a bit. And depending on where we go with the design, the force main is 740 to 1,100 feet long. We have a smaller pipe size because we're looking to keep the velocity inside that force main up. We want at least 2 feet per second for the Vermont regulations. But if you actually look at the velocity that's required to reanimate settled grit and solids on the bottom of a pipe, it's closer to 3.5. So at 2, things keep moving, but if something drops out, at 2, it stays there. At 3.5, it gets pushed along. And the wet well diameter is probably would be about a 5-foot diameter structure. The depth varies by location. So you see there 18 to 29 feet. Could you go to the next one? So we're gonna look at each of those 3 sites and just look at what a design there would entail. So that green little structure in the middle of that parcel next to the gravel driveway, that's the hatch for the pump station now. This site is very small.
This is like next to Old Brooklyn Court,
Yes.
Yeah,
You
That's
go
right.
over the bridge, it's on the
That's
right
right.
side.
where it is now.
you can't see the control panel because it's covered by a tree.
I can't see any of it.
Yeah, there's a shadow, but that's right there.
Okay,
Hatch, and then
Yeah,
this is the control panel.
yep. Thank you for pointing that. So the site is just about all you see there. Where the driveway, a little bit over from where the driveway ends, on the right side and at the far side. And you can see that there's somebody's driveway over here. Very tight site. I would have concerns about how the contractor would be able to excavate this all out without having their equipment be in the road. They're gonna have something to dig with. It's probably gonna have to be pretty large because of the depths they'll have to go down to. We might be looking at shutting down one lane or having the road deviate out, have around the construction site. It's gonna be challenging. There's also power lines that just off screen here. There's large trees that are coming over the site. You'd probably want to take some of those down first. You don't risk that any of that stuff
The
falls.
current picture, they're not, they're already
they've
gone.
already gone down.
Oh,
They're all
did they
gone.
fall since this?
No, they've fallen since that picture was taken.
Okay. Well, so maybe less of that type of concern. There's also wetlands just beyond the edge here. It drops off a bit and then right, that's why it's in the floodplain. It's got wetlands right there too. So we have a site that's in the river corridor, a site that's right adjacent to a class 2 wetland. And as we talked about, it's in the floodplains. To build back a new pump station here, we would recommend that that hatch not be placed at an elevation that gets fully submerged during a flood.
Yeah.
What we're talking about is a raised platform. I have a concept in my next image, but I'll have to explain what that is
Should I
exactly.
go to that next image now? Or not yet?
Not yet. We have, so a traditional pump station, precast tubes that end just a little bit above grade. And there's a hatch there and you got the control panel. Because of the floodplain concern, you can't just build it above grade like it is here. You have to lift it up so that that hatch is well above the floodplain elevation grade. What that looks like is the tube that would normally end right here, that circle you see, comes up further. We would have to build a working platform with a staircase up. Because it's a platform now, it has railings. We would put the electronics up there, a backup generator up there. And so it's large enough to house the electronics, the hatches, the generator. It ends up being pretty big footprint. Steve and Josh asked that we come up with some concept renderings, concept drawings, show what this might look like. And I just used some of the publicly available AI tools and came up with something. It's not precisely what it's going to look like. It's like a preliminary concept. If you drove past, this is sort of what you would see.
Before we look at that.
Yeah.
Some of these things like the river corridor, the wetland, the special flood area, because it's an existing site. Will that be easier to get the okay on those things? Cause it's our existing site versus if we picked this as a new site,
I don't,
like from a grandfathered in
Yeah.
perspective?
Yes and no, like you still have buffers, but because it's, if you're replacing in an existing, the minute you expand that footprint of the existing, you start to trigger.
That
Yeah.
stuff. Okay.
Yeah. You still have to protect the site from erosion control into the wetlands and all that type of work. The permits that
And
are
then-
involved.
Then obviously, we can't use the pump station while construction of the new one that's happening.
That's the other big component is because the site's not large enough to have the new station go in adjacent, allow the existing one to operate. There comes a day where this one's finished, all you have to do is a tie-in with some piping in the street. Then this can start being demoed. This project,
PMP can just drive over the bridge if it's not a flood. when they're pumping out the pump station.
Yeah, I mean,
don't
but
have to go all the
still,
way
I mean,
around.
last time we did that, it was $32,000. And it's gonna be considerably longer to construct,
imagine
to
it'll be
demo
weeks.
this, construct a
Yes.
new one.
Yeah.
Right, they will have some standby generator and a backup one there with bypass pumps handling the flow full time while that one's down and they're building the new one.
So wait, so we wouldn't be hauling, you would set up a separate pump.
That's how, yes.
Yeah,
We wouldn't.
I
be-
would,
so
I would
less-
propose, so the trucks aren't running
Right.
around the
As a
clock.
workaround, it's
Yeah.
just gonna be
Yeah.
more expensive, but not as expensive as hauling. Hopefully not.
I bet it's,
you start renting pumps and generators and for, time
Yeah.
adds up.
So
Yeah.
Eagle Scouts with buckets?
You can't do it with Cub Scouts.
The Eagle Scouts are always looking for a project. This could be great for them.
So now that I gave you the disclaimer, we can look at the next one. It's, again, it's not final at all. It's just gonna represent what this might look like.
Oil production platform.
There you go. I mean, essentially,
Yeah.
that's what it is.
Yeah, and you can see that during a flood, because the hatch and the
Yeah.
electronics and everything are up there, they remain out of the floodplain. And there, I think maybe to get ahead of the question, what happens during a flood? You can imagine sort of becomes a little island.
Yeah.
That's why we would put the generator there, so that if there was a power outage, the pumps are still gonna run. There would be a period where, unless Steve wanted to put some waders on, it might not be accessible.
So you're
The last two floods, it would be inaccessible. I
Yeah.
mean, I couldn't get to the control panel.
Right.
and I don't love to spend more money, but back to the jumpers on the bridge, I think you need to put a fence around it.
Yes,
Block
so
it.
that's one of the, there's no
It's not-
screening around this, there's no
Yeah.
fencing.
Yeah.
I can only tell the
Yeah.
AI
To do
so
so
many
many
things
things.
before it doesn't want to agree with me.
But I could see that being an appealing place to try to access.
Yeah,
if there
somebody's
wasn't
certainly gonna go up there and
fence.
spray paint your
Oh,
controller and everything like that. Yeah. Okay, so just so that we have something to starting visual point. Um. Total project cost over here probably looks something like the bottom line you see over here. We're assuming the Homa pumps, which I don't think we ever circled back on.
Yeah, I mean, I know what you're talking about, so.
We can get into that if you want to switch to one of the other manufacturers, but if we switch to one of the other manufacturers, it goes up a bit.
Yep.
Just a bit.
If
Hmm.
we were to retain this location, could we utilize the old bunker as part of a form to cast a replacement bunker?
I don't think you'd want to. It's a 75-year-old piece of steel that's been in the ground.
Yeah. It's
It-
pretty ripe on the bottom.
Yeah.
I've heard that there's some water down there sometimes.
Some days,
Some
it's
days.
been pretty good since we replaced the sub pump and got the dehumidifier and everything working.
So using the
Drought.
existing bunker as a form to cast a new bunker is not practical.
It,
Well,
the, isn't some of this
underground-
precast?
most of it is.
Yeah,
Yes.
Comes
I think I
precast.
lost you what you were asking.
yeah.
Underground, it's a continuation of what you see here.
Right.
Precast concrete with a big buoyancy lip way underground to
Oh.
prevent any rising when the flood comes in.
So a much smaller diameter than the current bunker.
What's the diameter of the current?
No, I think this one's bigger in diameter.
This is,
Yeah,
okay.
because you're saying it would be a 5 foot
Yep.
diameter. Well,
The bunker.
I think the one down there, just
Hatch.
using my eyeball, is more than a 5.
it's, yeah, probably a little
A 6,
bigger than
maybe a
that.
7.
Yeah, there's not a lot of room down there
No,
though.
it's not large, but
Yeah, it opens up probably twice the size, no, probably 2 feet bigger than the hatch.
hatch that's at grade, that's just
Right.
Yeah,
the manhole to get down and then.
I can look up the
Yeah.
dimensions for you, but I think this one's bigger.
Okay.
So we've done the same thing. There's a price for each of the components, subtotal, and then we have the contractor's markup, the tariffs, contingency at this point in the design, because it's so early, engineering, legal, it all comes down to about 2.7. And this includes some work on the force main and the sewer manholes that we've talked about too. Okay. It's all three of the items.
Everything you've talked about so far is 2.7.
That's right. At this point, in this planning level, right? It's not a final design cost, but it's about where we think it is right now.
Okay.
Okay, so that's location 0.
Eric, what's
Yes.
I mean, the height is about 7 feet.
A bit more. I think we're using 9.
Okay.
The existing rate at the site now is 305, 306, and we want to be at 313.
Okay.
Okay, I'm all set. So, location 1, if you're imagine yourself standing at the photo before, if you just did a 180, now we're looking the other way. There's the gravel road that goes to the water house. Round Church is further away, up on your right. The bridge is on your left. I like this site better. It was my gut instinct looking at the site that we could just go over here. This would allow for the construction of the new pump station to be performed while the existing one is operating, and then you could switch over, which is always a really nice, convenient feature.
I'm
You
sorry.
have a question?
Go ahead.
Hi, Kevin Cage again from Richmond. Earlier you said that other options were thrown out because they were on private property. This is private property as well, and so is your next thing.
I think that the information that we looked into said that the historical commission owns this lot.
But they're not affiliated with Town of Richmond.
Oh, okay,
So it is, yeah, it's not like it's an individual homeowner, but it is not town property.
gotcha. Not town property. Okay, gotcha. All right. But the other ones were private residential properties. I guess that's how I should explain it. Let's see, this one would also require something similar, although less height. The grade over here is about 2 feet higher than it is on the other side of the street. So with, instead of a 8-9 foot structure coming up, it's closer to a 6. We are also in the buffer zone for the wetland versus being potentially in the wetland, which is forgiving for the permits and for the construction. We're still in the floodplain, we're still in the river corridor, however. There's no overhead power lines, there's no large trees, the site's a bit bigger. We already have a gravel road through there, which, if there's an easement that the town has through this lot, we would try to stay on that with as much as we could. So, next slide.
Morgan, you have another question?
I'm sorry.
When you talk about the height, are you talking about the top of that rectangle, the underneath the rectangle? Where does the height measurement go?
To the ground surface at the pad,
To the what?
at the pad. Did that make
Right,
sense?
so
To the top
So-
of the,
If this was the raised structure,
Right.
So I think the rectangle is what you're calling the pad.
Yeah.
Like there's the cylinder and then the pad you're saying is the rectangle, right?
right,
At the top of the pad.
correct.
Thank you.
sure.
That gets it above the flood height.
Right.
I
I was just trying to think visually.
Mhm.
No,
So in this rendering, it gave me some trees for screening. You can see it looks a lot like the other one. It would probably be higher than what you see here. I tried to be shown a little bit higher. So imagine that a couple of feet higher in your head. But the same idea, design wise. A raised pad with the concrete cylinders coming up, staircase, railing, generators on top. We would do the same thing. We would, for security reasons, put a fence around it. We could do trees around it too. you don't really have that option at site zero because there's not much space there, but. Yeah, so then this project would be a little bit cheaper, we figured. They wouldn't need to do any of that bypass pumping. And it just becomes an easier site to deal with. Sometimes the cost goes up with more headaches and tighter work zones and traffic control and all that type of thing. So we have this one at 2.5.
Morgan, Fran has a
I'm
question.
sorry, Frank, go ahead.
So right now we're looking at a concrete structure with ramp, with ladders and whatever. Is there a way to create a structure around that that is more pleasing to the viewing public as they come across the bridge?
It's an option. Are you talking about maybe we, put siding on something and make it look a little bit more like,
Like,
yeah.
I mean, the viewpoint, we're all historical society members.
I had a feeling.
So, the look of the round church where we come across the bridge is
Yes.
really important. To the Richmond residents.
Yeah.
And, right now we're in the tourist season and tourism.
Yeah.
So that, if this was, ended up being a chosen spot, if there was a way to make it look more aesthetically pleasing.
I understand. We choose those materials because they're resilient and, if a flood came along, concrete can get wet, metal can get wet. If we move to something like that, you'd probably still want to think along those lines or else, because in the floodplain, you wouldn't want to use, cedar siding and, typical residential level things. They do make siding boards that are made out of concrete now. PVC type stuff. And a lot of them end up looking pretty much the same, but just it has a higher cost to it because it's not pine. So there's just that thought.
To your point, it strikes me that if concrete had to be used, the roundabout in like Jeffersonville and they have those bunker things and they painted like the murals, like maybe
Oh, silos, yeah.
the silos, like
Yeah.
maybe
Mhm.
if we got to that point, there could be some extra
Going back
of that kind of
Going back
stuff.
to the stuff along the sea coasts, I've seen that they make some of those structures look like lighthouses. If they're on the coast and that, yeah, it's something that communities certainly think about.
And there's some architectural, effects you can do with concrete.
Yeah.
In the forming of it.
It would be interesting to do a site visit, I think,
This,
as we go
This-
further along.
the round church is important to the town. And I'm not looking to cause it not to be an attraction for the town. And I mean, but we've got to do something, otherwise every flood, we have to replace the pump station that we have. We've got to do something. I'm looking at trying to give you guys the best option for what we're stuck with there.
We realize,
But,
sure.
and, my thought was, instead of being all concrete, that it could be faux stoned or something along that line, maybe. To give it a full look that would blend in better. And then put some trees and stuff around it.
I know this adds cost, but maybe you make it look like a smaller well station or well house.
Yeah.
Yeah.
We are certainly cognizant of the issue.
No,
And
and-
need to solve it.
Yeah,
Yeah, I first came to Josh and Steve and their initial reaction was, we want to make sure we involve all the members, historical commission. They didn't feel like it was just on them to pick one of the alternatives and pursue that. So
Why didn't
It's-
you go farther onto the wellhead property?
The further away that we move, it's just more piping that'll have to go underground.
It's more piping, but what, is there anything prohibiting you going?
Well, we'd have to go in for source protection.
But what is the circle for source protection?
I'll have to,
We looked that up once.
huh?
75 feet.
Yeah.
Yeah.
Yeah,
Just throw in there and
but there's
put it on
also,
your own property.
there's also, chlorine contact chamber that's in there. That comes out to the road and goes back.
So it's gonna make the pipe, the force main coming out of it
A lot harder. I
I
mean,
think we also move away from where the easement and the,
well, this site across the road
yeah.
is actually, I thought there were two houses that would end up possibility, wouldn't be gravity anymore.
Yeah, that could be,
Mrs. Foley's in the next house, they wouldn't be able to use gravity.
Well, but,
Yeah,
it'd be something we'd have to look at, the further away you move it, yeah. I mean, you could probably leave it on the line where it is now and just do a new line off of that, which is sort of what the location 5 idea follows. So that we don't have to think about putting pumps
Yeah.
in people's houses. But,
Do we want to move on to 5 and?
Yeah.
talk about-
sure. Yeah, it seems to be there's a lot of questions about that, so we'll throw them all out there and then have a discussion. So we like this site. What the zone that we were eyeballing is outlined in that red box on that photograph. We're trying to keep it as away from the Brown Church as far as practical. But what happens is once you move it further away, now the grade starts dropping back down. So at this site, we're actually outside of the floodplain, which was the driver for keep including it in discussion still. It's also not with any known wetlands. We wouldn't need that raised platform anymore. So you'll see in the concept on the next slide that it doesn't have that big raised brutalistic concrete structure shown. We could build it down lower to grade. We could still do the same type of things with vegetation to screen it or another type of structure. Question?
Just quick one, Kevin Kitcher again.
Yeah.
6 inches above ground, couldn't that be made flush with the ground like the original pump house?
We try to lift that up a bit for snow reasons and I guess rain reasons too, precipitation.
Yeah.
It helps you, find it if it was gonna snow a
Bury.
big amount. Yeah, you see it, you won't have plows hitting it type of thing. I've seen that. No, well, no, I mean, when Steve plows around it so he can access it.
yeah, if we had to access it. It would be no higher than the one we currently have over on the other side.
But that could easily be hidden by a hedge on like something 8 or 10 feet.
Right.
What would you need for access space?
What did you say, Fran? I didn't hear
For
you.
access.
There's, I see that at the pump station now, there are trucks there, but what do you need?
For like. pull-
Ideally, we would have to have a place if we had to pull a pump. So we would need an access for
Yeah.
a truck to come in with a crane.
But that would be like emergency,
Right.
like,
So that'd be.
But that happens, so you
Yeah,
wanna
It
have,
does.
you wanna have a path.
And
to
it is
Yeah.
routine maintenance.
Right, be able to pull up next to it.
And yeah,
So, but could it still be grass?
yeah,
Or gravel. It wouldn't necessarily need to be paved. I think the path to the water house is gravel
Yeah.
road right now.
Yeah, but this,
the,
here now
closer.
you're getting into the view.
right.
Understood.
There is a telephone pole right where we proposed it, and that was one of the reasons that area came up. The other thing we talked about with this location, because the structure is down low, we can landscape around it so it
Yeah,
makes it better. But we also talked about relocating the control panel to the back of the church. So it's not in the view out by the road.
Why don't we flip to the next one? That'll help.
Would you consider suction lift?
We didn't at this site just because of the depth.
Okay.
We looked at that at 0 and 1, and we thought that it would have net pressure suction head potential issues. So we stuck
Yeah,
with
gotcha.
submersible. I'm gonna get up and point actually.
They were asking about a different type of pump station, which is called suction lift, where the pumps are up out of the wet well. And there's engineering design issues with depth, and that would have to pull up. Because of.
I can only lift water so.
Like it's
Efficient.
On the suction.
So that's suction.
So. You notice the image in the last one, my red box was over on the side, it came in closer to the pole, I think. This would actually have to be over here, so just as a disclaimer, as everybody sees this.
Do the current lilies hide something? Or
No.
they're just there?
Steve was mentioning the control panels. What we could do is run a conduit across the yard, hide it behind the stone church. And that way, some of the vehicle traffic by Steve and his guys, you could just park in the existing paved area and walk behind.
Could you even move the control panel over to the well house?
Or under. Inside the vault of the building,
Which one?
move the electrical panel down into the vault itself.
They don't recommend that at all.
If it floods, it would fry the whole
Yeah,
thing.
everything would,
The sewer gas is in there.
The hydrogen sulfide that's created from.
In the
wastewater
gases
would eat
would-
the control panel.
yeah.
Not good for the
Not out
electronics.
a year or two,
Yeah.
and then you feed into it,
Yeah.
and I have to purchase.
We hadn't talked about putting it over by the water house.
No, just because it was a bit further away, we hadn't thought that.
I mean, it's cable and voltage drop. I mean,
That's what I'm thinking too. I don't know how far away we could get with some of these. Cause they're low voltage,
Yeah.
low wattage, the pumps.
If you went to, sorry, design options, your concertor type, those flight pumps that have the VFDs right in them.
Yeah. We still have maybe the same concerns with everything else though. The level controls and the alarms. I'm also thinking-
Exactly where, on the, where it would be.
It, more so in this area. The shadow hides it, but there's a drop in the slope and we were targeting. You know, with like the Venn diagram, right? Here's the round church, here's the floodplain that we needed, right where we could get it.
That would be a hatch, what, 4 or 5 feet in diameter, a foot off the ground?
Probably a bit less than that. That's where the 6 inches comes from. Just minimal depth off the ground, keep the weather off of it, wet out of it. 5 feet diameter, 6 feet diameter, something like that.
Could you raise dirt around the 6 inches to bring it flush? I know you wanna plow, my driveway, I gotta plow, I put stakes in the ground, but I mean. Do something like that so it doesn't stand out as much.
yeah,
It's a possibility of planting bushes all the way around it. some
Yeah.
decorative
Just,
way.
I'm not saying you have to. dig it
Right.
out right here.
I
but
mean,
just,
my whole idea when this site came up was it gets rid of that humongous thing sticking up
Yeah.
Agree.
on the, across the road and, or below the church. And I mean, ideally, we would try to make it as camouflaged in there as we could.
Out of the floodplain.
Yes.
We are out of the floodplain there, and that's what gives us the ability to do some other things. Because we're out of the floodplain, if we located the control panel behind the round church, we don't need a standby generator anymore because we're out of the area. It reduces some of the necessity and some of the things that we want or have to have.
have to access the control panel?
You know, I mean,
I'm thinking of winter when the snow's on the ground.
right, I mean, it's no different than what we have to access, the one that we get now. I mean.
But how often is that?
once
I
a
guess we
month?
just don't know.
Yeah, a couple times a month.
Okay.
And it would be, you know, we would have to have a, you know, either shovel a path to it or, I mean, currently we do it. No, I mean, most of the stuff at the control panels are accessible. You don't need a crane or anything. The pump station itself, routine maintenance, pumps need to be pulled. We would have to be able to access that
You
with,
wanna be able to back the truck up.
yeah.
Next to the hatch.
And if that is just a grass place, you know, but so we can back off the road safely, it's level, that's what it could be. You know, I envision maybe some rock terrace or something on the backside, cause it does go up the hill. It might not have to stick up 6 inches on the backside, but we kind of try to blend it into that hill as best we could and make it as obtrusive, you know, as we can.
The only other piece of this that we haven't talked about yet is the cost. This is the most expensive option, because of the depth of the excavation that would be required. Right, the grade comes up here, so we're digging deeper. This is the one that we're probably close to 25-30 feet deep, somewhere in that ballpark. What the cost you see here is, Josh, I alluded to it with an email to you. I had a chance to look into it a little bit more. Right, this is our first cut at the cost estimate. With another look, these over here, we probably have to drive sheets.
What
that
does,
means is
what does that mean?
drive, I guess, drive a big plate down in the ground.
Because of the road.
We wouldn't wanna have risk that the shearing, any shearing of the soils gives any sort of safety concerns for vehicular traffic. We also have a utility pole right there, wouldn't want that undermined, come swinging over. What the sheets look like is a crane that drops a large sheet, probably 40 feet tall, drives it into the ground. Circle the area, we probably only have to do the wet well, right, because the valve vault is gonna be a lot higher up. Kind of reduces the total footprint that we're sheeting. But that adds a big cost, so.
So you're talking about driving it straight down?
Yep. And then you
And
dig out,
there's rock as well in this area. According to your report.
we don't actually have any subsurface investigations done yet at this stage in the project. We don't know where bedrock is at any of the 3 sites, which is a big thing, obviously. The next steps would certainly be going out and making sure that all 3 sites are still viable options, or the one that we decided to go forward with.
This question is actually for Gary. I don't know where our electrical and water lines run.
The
Are they
forest
there?
water line for our sprinkler runs right off near the power pole. Runs over and our buried conduits for power run
Off that same.
near that and go around the back of the church. And the existing power line that we use now runs pretty much straight line from the church to the second window on it, right? Showing that. So all those are in the way of your plan.
Okay.
So we were thinking of redoing the conduits.
Or not redoing the conduits, right, using the conduits. Right now, we put them in, but we haven't run the lines in.
So the cost I had on here is close to 2.9. I think the sheeting that would be required for that deep excavation brings the cost up to closer to 3.1, maybe 3.2.
Would it be as high if you hit bedrock quickly?
There's a couple of things that would be in play. If we hit bedrock high, you would need to remove that rock, which
Yeah.
also can be expensive. So
Suppose attaching your sheathing, whatever, to the bedrock and not have the.
I've seen that done on another project. They drove the sheet to the bedrock. But again, the rock still needs to be removed. So that's if they're hammering it, they're blasting it.
Yeah.
That's a big expense too.
I don't think we should be hammering and blasting that close. Nope.
Well, that's,
Yeah.
I'm glad we're having that conversation because the driving the sheets is they use a vibratory hammer to push it
Yeah.
down through. So there's that in addition to the other concerns.
They did it up by the fire station for the new bridge. The lower side of that near the river. They drove pylons all the way along that whole side sheets.
Yeah.
And then they pulled them out after construction was all done.
Yeah.
I'm very concerned about any type of blasting doing that close to the church.
Yeah.
Mhm.
Without doubt.
There's things that you can't replace in that building.
Yeah. Yep. Yeah.
Everyone's.
Yeah. I wish I could tell you it wouldn't have any damage done to it, but sometimes. With the.
Well, the next
blasting,
step is
the grade.
to
the bedrock
determine where
question, yeah.
bedrock and what's there.
Yeah.
What is a ballpark figure for doing a geotechnical core sample to see what's down there? I guess you'd want to do that anyway.
We would,
Yeah.
certainly. Before we went out to bid with the project, that's something that we would need to know.
Right,
Do they,
So step
Uh,
2 is the final design,
right.
and that's
You don't
usually what
core
we
drill
do, is we're
anymore.
identifying
You
the
just don't.
sites for it at this time. You don't get to have all the information right off the bat, or else the preliminary design kind of becomes the final design.
Right.
Not terribly expensive to do some probes to find where bedrock is. And we would probably do a couple at each one of the sites to verify that it wasn't just a boulder or a big cobble that we hit, that it was consistent, that it's bedrock.
Would there be different things in the ground, like the bedrock you're talking about? If we looked at the space that's between, like the road, the two roads, like the little green space that's there, the park?
You're talking about up this way?
Yeah, on the other side of,
problem, Aaron, if we keep going up the hill, all of the houses below that, including Gary's, would end up being on pump stations. We physically have to pump their septic back up.
We used to have a
Okay,
straight pipe to the.
but,
river.
well, and like,
Yeah.
yeah. And I totally understand that, but would we be looking at, because it's not on a slope? Would it be worth, if they were checking for bedrock, checking there as well?
We didn't look at the park.
Yeah,
That's what you're talking about.
yes. Well, and that I also feel like would be a little bit less, I feel like this is the angle that everyone takes the pictures at, and I don't want to speak for the Historical Society, but it does seem like if you put something similar to what you're proposing here in the park, that's a little bit less of a beauty area. We
We
could
didn't-
still make it pretty, and it would be costly with pump stations and stuff, but
It would
is
be
there a reason
costly.
why we haven't looked?
Yeah,
There?
just that, the further, so we're at a very deep excavation at this site.
Mm-hmm.
The grade still continues to climb, or maybe it levels off a bit. I can tell by the photo.
Plus,
right?
there's a lot more.
That's more very deep excavation that has to occur, and that adds a big cost.
The more people you have to add to the pumping.
Does that add the sheeting though, if you're away from
Yeah, when you
the
get to.
telephone
steps,
pole?
You pretty much have to, unless.
Basically drawing, you can't dig that deep.
Yeah, if you,
Okay,
with trench boxes, you can stack the 2 of them, maybe 3 of them if you've got a good system. But
That's getting.
the
all
other
across
option
the
is
church,
open
too.
cut, and you need about a good slope or some benches dug out in the earth.
mhm.
And now you're talking about, we're 25-30 feet deep, but now we're also twice that wide for a safe excavation. Yes.
Yes, Gary.
I'm sorry, Gary.
So, I have another proposed site I'd like to show you, but, before I do, I just want to point out a couple of things about the church. The church is a National Historic Landmark, and while there's like 3 levels of historic recognition in the state, the state register of historic places and the National Register, and those have thousands of buildings on it. Then you get to the National Historic Landmark, and in the 60 years this program has been in effect, there are 18 buildings in the state that have obtained National Historic Landmark. And this building was picked number 12, so it's a very major building, and the Historical Society has worked really hard to create that open view. We bought 2 houses, we rented them for years, we took them down, we reshaped the lawn a little, and we've been pretty bullish about not having that touched. And to the point where there was an offer of a donation of a flagpole to the town many years ago. And we've fought that because we just thought it changed the pristine nature. And what we're talking about here is much more major than that. I did talk to a couple of people at Vermont Division for Historic Preservation yesterday, and they did say there's a higher level of review for national historic landmarks. So I don't know what that translates into, but I would like to just show, Josh, could you get the one that you showed early on in the report that had the manholes and the 100-year floodplain? Yeah. So could you enlarge right around number 0? Yeah. Right. Come up just a little bit. Yeah. So, get my bearings here. So there's your 50 by 50 foot wellhead.
That's the pump
So,
station.
Fran sent me the report last Friday night, and I ended up and read a lot of it. And I'm looking for an alternative because I agree we have to put this somewhere. And John Cart's property has a nice bank that's out of floodplain. And he's pretty close. The elevation change to the base of that, I think, is about 4 feet. I didn't set up a laser level or anything to check it. So I went to see John the next day, and I said, would you consider selling that corner to the town? And he said he was looking at maybe putting a little house in the corner there because he's sick of living here when house floods all the time. But I think there is space right next to it, and it would allow for gravity feed. I don't think you'd have to go much deeper, maybe another 5 foot deeper to get over there. And for me, the nice thing about that is that nobody's gonna see it.
Right.
He said, he'd be willing to relocate his driveway. These people have a right of way across his property, reshape that. I told him I would help him, whether you guys are interested or not, to go through and get a subdivision permit to do what he wants out here, just because I've gone through that a few times. But I think it's a real opportunity to move this where you have a bank, so you could set a concrete base in there, have all your controls at whatever level you want above it. And I don't really know what's involved in getting your line here over there, but.
Is that going down Old Brooklyn Court into the upper side?
Yeah, right now the driveway goes in, John's house is there, and Lonnie's house is here. Takes a hard left, kind of follows right along the white line, get out to their house, but John's willing to, bring the driveway over here and then bring it over to Lonnie's house. So, I mean, you could still do some screening for John and for Lonnie's, but for the rest of the town, we wouldn't have to see it.
Yeah.
And it's not an option that we looked at, I mean,
It's not.
because
If
it
you
was
tucked it-
private.
Yeah, if you tucked it in the back corner, I'm not volunteering, it's not my thing to volunteer, but same idea, if you tucked it in the back corner of that.
Yeah.
Cornfield,
Oh, yeah, but yeah, I think you get a lot, the same,
like, would you,
the distance from here to.
yeah, like if you,
here is only
Yeah.
less than a couple hundred feet,
Yeah, it's pretty close.
yeah.
would that meet your gravity requirements if you were in the cornfield, if the thing with John didn't work out?
Hard to know
You're talking
right
about
now.
in that,
Here,
yeah.
Well, somewhere in there, I mean, some of it's in floodplain like yours is,
The
but
problem with it being up in there,
if we were to give
Take a
you
pretty sharp
access to it.
we'd have to, I mean, we'd really have to look at,
You would need a legitimate road out there.
yeah,
If you ever had to get heavy equipment or a
Yeah.
crane or anything.
right.
Pipe it.
But if we could take the tractors out there, you could take a crane out there. Unless it was,
It, I guess I would really have to look at both those sites and I would like
Yeah.
Eric to
I don't
look at
think
them.
we're ready to jump on anything tonight.
Yeah, I mean,
obviously.
I agree, I didn't,
like Gary said, like, is it worth, I mean, I don't know, I'm not in
We-
control of the land, but is
the
it
two
worth?
things that we have to look at is elevation
Yeah,
and how deep we're gonna have to dig.
Yeah.
And how much space we would need to
to
do
do
it.
that.
And then the other would be, we would have to get an easement
Yep,
for a right of way.
from who?
The landowner.
from the landowner.
From the landowner.
Yeah.
Oh, yeah, but John, it would come with the deed for the property that John would transfer to. Sell to the town.
Yeah,
I mean, if it's a new site, couldn't you do it on the same footprint, 50 by 50 foot footprint? If you're not trying to take out the old one and build a new one, like at site zero?
well, I don't want to diminish what you proposed. It could be a viable alternative. I like that it's close to the existing one. I like repeating what you're saying. But it's on a private residential property, and so now we just have to verify that, you know, all the needs would be met. So
Cause
that's what Steve's saying, that
it's-
we have
it's not
good
just the
access.
excavation for it, there's gonna be the excavation for the inlet
The piping that leads
and
to it.
the
Yep,
force main.
Yep,
And if it ends up having to be 35 feet deep, because that's where we have to get it to make our grades.
How deep are you now?
I think that manhole that acts as the wet well is 12, 11.
Yeah, just about.
I think this land is more than 4 feet higher back there, so.
To be out of the floodplain, it's gotta be, what's that, the 100 year? It's probably 6, 7 feet at minimum higher. That's the 100 year is 310. And this is where that site is now is 305,
Street you're talking is what,
305 or so.
The manhole in the street,
5 feet?
Yeah, isn't that what I thought I said 5 or 6
I
feet?
thought you said more, I'm sorry. Yeah. Like you said, we can't solve it tonight. I just
Yeah,
would love you to consider it.
it's an option that none of us had thought about.
So let's just take one more question because it is 9:20 here and we've got Aiden, I think, has one more.
Only comment I'd make about that idea I like is that a lot of the construction on the other proposed locations are going to have effect of access to the church. Also the fact we use a lot of that green space for like concerts and many of our but fundraisers and so on that help us maintain that church. Having more of the work being done way off, I think would allow us to keep that intact. I just worry about a lot of construction for long periods of time
Yeah.
could significantly affect the visitors to the site. Or donation and such.
I know where he's
Good,
talking.
very good point.
I want to just throw out one
I'm thinking,
consideration,
the guy
it's
that
just an
owns all
idea.
this too.
Has anyone ever been to, Portsmouth, New Hampshire? One of the parks is down by the water, right? Beautiful gardens. I just want to throw out that any kind of landscaping or improvements, if that was something the Historical Society was interested, it doesn't sound like it, because I know it just sounded like you didn't even,
Didn't want a flagpole.
you know, want to flag it. I just want to throw out. Something like that could be incorporated into the project to have like a display show gardens or something like
Yeah.
that, that could be also, you know, like a public garden for the town of Richmond. I just want to throw that out, anything like that could be incorporated into this project, something to just keep in mind.
It's a good thought.
Call Mary Who.
Yeah, I mean, we've talked about just,
Tech, I mean, it could be,
yeah.
I get something.
Okay.
just something to keep in mind.
Well, we have a lot to cover still on the pump across the river there, so. Sounds like maybe Steve and Gary can get together to.
Yeah.
As well as John and.
Eric, we'll make arrangements and we'll look at the options.
Yeah, let's look at the site a little bit and then we'll go from there.
I mean, we're not saying no, we're just saying,
No, I know.
Yeah.
let's look at it. I didn't
Yeah.
even,
I think you should call Ashley too. And ask him about our piece of land that borders that.
Yeah, I mean, it still comes with right of ways for the piping and everything.
100%, but
Well, let's do some exploratory, I mean.
Yes.
And we.
you might call him and he might say absolutely not, and then it's right there, I don't know.
Did you, with that road that accesses the cornfield right now, would that access that spot? Or is that?
No, because there's a brook, but there is a road on that side, you just can't really see it.
Okay.
Okay, great. Do we want to touch base with Aiden's last slide or?
So the very last slide was just about, and we don't have to bring it up really, but it was just to kind of like the schedule and next steps and, you know, I think, Josh, you would have to toggle back to the other one.
He's already ahead of you.
You're already there, okay. So here we are, it's October 7th, this is our presentation to the commission. Next steps really would be that we enter into a step 2 design agreement that would be approved by the town, by you guys, and by WID is the Vermont Department of Environmental Conservation and Water Investment Division, that's what Lynette, that is her group. So sometime in November, looking to get that approved. We would then advance into conceptual, like our final design for the contract, actually contract 1 and contract 2, we would propose to do the design, all of it. And then you wouldn't build it until you did contract 1 and contract 2.
Do
But
we pick the location first, or do you do designs for like a couple of locations?
They're separate. and-
Oh, we're
Back.
off.
We're back at the other presentation.
Okay, sorry, I didn't,
should have did that, just.
I was like, man, that's really fast, got it, okay. Sorry, it's past my bedtime.
We'd enter into final design, looking to make a 30% submission to the town and to the state in April. Then we would look to do a bond vote for that contract 1 only, at some date that, I think next town meeting day is coming too quickly. So we would look to have like a special bond vote, date picked sometime in the future, and then complete final design by February of 2027. To put it out to bid, advertise for bid for construction and start construction in the spring of 27.
How, this is gonna sound bitchy, it's not meant to. How is a bond vote in March too soon, but a bond vote in April would be okay?
April of
26. Bond vote April to June of 26.
April's too quick. I think you're pushing more to May or to June.
Okay.
What you would want to go to bond vote is you would want us to get past 30%, so you had a really good number to present to the voters. And you would want to have us do public outreach so that you could you know, you can inform the public, what is the need, what's the importance.
It's not the first time that they're seeing it all.
So. Step 2 design agreement, how quick can you get it? Not until November.
It does take some time. I'm not sure if Lynette's still on the call. There is some time back and forth with the contractual language in it. We have it pretty much drafted. It's something that we could get started on pretty quickly.
I'm just concerned if we go for a bond vote when it's not a time that people are coming out to vote on other things.
And here's the thing, you do not have to do a bond vote until you're closing in on 90% of the design. So it could be the election time, November, it could be the following year's, 27, yeah.
I just
That's
think,
something that we
We
would have.
did a bond vote. Gosh, what was it for? It was 4 or 5 years ago, and it was not done with anything else. And we left the polls open at the town center for like a month. And people, I forget what the turnout was, but I remember it was a steady flow of people that would come in and vote on it. It was for.
I just think, I don't, my gut is with the amount of money.
You don't have to make a decision about.
Yeah, I think we need to do it when everyone's coming out, not when people are just gonna come.
A special session.
If they feel real passionate in one way or the other.
And again, it can happen at any point, before,
I mean-
you just can't, you cannot go into construction without having an approval from your voters. The bond bank.
Do that. That makes sense.
So that's just, it has to happen. For the construction. We can have that if we need to. So, and then, step three is the construction phase. So that application would go in sometime in January of 27, and then bid and award the project in, you'd want to do about a 45-day bid period to get good bids and award it for starting spring construction. And then we anticipate that is about a 1.5 year construction period. So I just wanted to put this up there so you see that, you wouldn't have an upgraded plant that's till November of 28. And here, right now it's October 25. So.
Can I ask you a question? So is there a certain time of the year that they're better to put things out to bid?
Yeah, for sure. Certainly.
There are.
Sometimes it's really good to get the bidding phase that starts now so that you're under contract with a contractor, maybe like January 1st. And that gives them maybe January, February, March to do their shop drawing submittals to the engineer and to start to order things that have a long lead time, And these days, anything that's electronic with a VFD has a really long lead time. So that way he can have some of those shop drawings out of the way, he can have things ordered, and he can start digging, so for concrete, maybe like by April, sometimes March, but then you don't lose that first construction season. If they can get structures in the ground, then they can tent them and they can do winter construction the following year. So yeah, there is a little bit of a rhyme and reason to it. For sure.
I was just looking.
All right.
So next steps would be to talk more about the loan payback strategies. And I think if you wanted to have a special, walk through with Aiden on the tool, we can definitely do that with you. It also sounds like really exploring this other property and kind of taking a look at that.
Yeah.
Before the pump station PER can advance any further.
Yes, yeah, we'll talk. It would be good to have maybe a whole meeting or part of a meeting where Aiden can walk through playing with those spreadsheets. So.
And I think I heard from you that you're okay with me finalizing the PER for the treatment facility and submitting that to Lynette.
Yes.
Mhm.
We just refresh my memory, there was something we signed for the environmental wetlands mitigation survey.
I think you signed an amendment to do some pre-engineering.
And that included
And that's
the-
survey,
Yes.
wetlands, is Paul on the call? He's available. We can get that, I mean, it's getting late, we can get that information for you, I mean, Josh, you have that contract.
Yes,
Yeah, I think I sent it back already.
Yeah.
You did,
We've already
yeah.
already-
We've got. Now they wanna know what they signed.
We have surveyors out there today.
Yeah.
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 I think geotechnical is.
I don't think there was anything about that. No.
The surveyors were out today and
okay, I just trying.
Wednesday and Thursday.
I heard they got some pushback already today, being on private properties.
Just one person.
Just one.
One person, what?
Nothing.
Okay, all right, any other questions or comments? Thank you very much, Eric.
You're welcome.
Kristen and
Sarah.
Tara, I'm sorry.
And
Sarah.
Aidan.
And Aiden, thank you very
Lynette.
much for past everybody's bedtime. We really appreciate you staying up. And we'll be back in touch.
Thanks for having me.
Yes, thank you, Lynette. I'm sorry. Yes.
Do we need a motion to adjourn?
So
I guess we don't. Yes,
This is Aaron. I move that we adjourn this meeting.
all right. Stay.
Good night.
David,
Morgan, I motion adjourned. Thank you, everybody.